महनाज आफरीन, आपसे निवेदन है कि मैडम का संक्षिप्त परिचय प्रस्तुत करें।
Thank you, ma'am. Good morning, ladies and gentlemen. Dr. Chandana Kumari is a dedicated educator, distinguished professional, and a social contributor with a PhD in computer science engineering from BIT Mesra, Ranchi. Her doctoral research focused on the development of efficient meta-heuristic algorithms for image segmentation, showcasing her expertise in advanced computational techniques and innovative problem solving. She has journeyed her academic and professional as a part-time French faculty at Shane International School, Jamshedpur in the year 2013 to 2014. Faculty IT and CA at Karim City College, Jamshedpur in the year 2011 to 2013. Automation consultant at Tata Steel in the year 2008-2010. Computer teacher at Kerala Public School in the year 2003 to 2005. Faculty at Dr. Zakir Hussain Institute of Technology, Patna in the year 2001. Dr. Chandana Kumari's teaching and consulting career spans various disciplines, including information technology, computer applications, and French, showcasing her versatility and commitment to education and professional development. Her achievements as Pan-India winner at Asiana Supermoms Season 5 in the year 2021 sets her apart as an example of leading women in the city. She has successfully translated the course Natural Language Processing offered by IIT Madras during COVID-19 in the year 2020. She is a certified announcer with All India Radio Jamshedpur. She has socially contributed and demonstrated a strong commitment to community service through organizing COVID-19 vaccination campus for senior citizens, conducted donations drives to support the underprivileged, as well as led free computer workshops for senior citizens to enhance their digital literacy. Dr. Chandana Kumari, diverse experience, academic excellence, and social contributions make her a distinguished individual, blending professional expertise with community-oriented initiatives. We welcome you, ma'am, here. Please.
Thank you so much, ma'am. Here, Dr. Chandana Kumari, in front of you. Today I'm presenting, इसको connect कर दीजिएगा please. The Artificial Intelligence Ecosystem. कल की जो हमारी टॉपिक थी स्टूडेंट्स के लिए वो अकेडमिया रिलेटेड थी, थियोरेटिकल नॉलेज से रिलेटेड थी. आज का डे जो है वो डेडिकेटेड है इंडस्ट्रियल. So practical approach of those theoretical knowledge should be there in today's session. So practical approach की जब बात आई तो कल के सेशन के कुछ फीडबैक मैंने स्टूडेंट से लिए और स्टूडेंट्स के फीडबैक के अनुसार से इन लोगों ने कल मैंने जो यहाँ पे कुछ प्रेजेंट किया था उसे इन लोगों ने गूगल किया. बेसिकली हम लोग सर्च करते हैं, सर्च इंजन है हमारे पास, तो इन लोगों ने गूगल किया और ट्राई टू क्रिएट समथिंग. सो हम सभी जानते हैं कि क्रिएशन, ब्लूम्स टेक्सोनॉमी का जो टॉप एपेक्स लेवल है दैट इज़ द क्रिएट, एंड एवरीबॉडी वांट्स टू क्रिएट समथिंग. और हमें वहाँ तक पहुँचने के लिए बहुत सारे स्टेप्स को क्लियर करना होता है. तो क्रिएशन बच्चों के दिमाग में, आज के स्टूडेंट्स के दिमाग में पहले आ जाता है. जो उसका बेसिक स्टेप्स है उसको वो भूल जाते हैं और सोचते हैं कि हम जल्दी से कैसे क्रिएट कर लें. ये आज के जनरेशन का है जो भी है. आप उनसे कुछ भी पूछेंगे तो बड़े स्मार्टली तुरंत गूगल करेंगे, चैट जीपीटी निकालेंगे और आपको बता देंगे सारा कुछ. और मैंने देखा है कि आपको बहुत कुछ अच्छा एग्जीक्यूट करके भी बताते हैं कि मैम ये हो सकता है, ये हो सकता है. तो एक इस 10 साल में यहाँ जो अलकबीर में मैं पढ़ा रही हूँ टेक्निकल इंस्टीट्यूशन में, वहाँ पे मैंने बच्चों से भी बहुत कुछ सीखा है. बच्चों ने भी मुझे बहुत कुछ जानकारियाँ ऐसी दी हैं जो शायद मुझे नहीं मालूम थी, और यही जो गैप है उसे ब्रिज किया जाता है बच्चों से भी सीखकर, और हम भी उन्हें कुछ ट्रेंड करते हैं. तो कल के सेशन में इन लोगों ने कहा कि मैम एआई की बात हो रही है तो आज प्रैक्टिकल अप्रोच में आप हमें चैटबॉट बनाना सिखा दीजिए. तो एक कॉन्सेप्ट आया कि आप यहाँ से लेकर क्या जा रहे हैं, चैटबॉट लेकर जा रहे हैं, कुछ तो लेकर जा रहे हैं जो आप क्रिएट कर सकते हैं एआई के जरिए. तो सबसे पहले जो थियोरेटिकल अप्रोच है उससे प्रैक्टिकल तक कैसे जाना है, तो हम लोगों को ये समझना है आज के टॉपिक से, और आज का जो टॉपिक चूज़ किया गया था वो झारखंड काउंसिल ऑन साइंस टेक्नोलॉजी इनोवेशन के ज़रिए ही है ये टॉपिक, क्योंकि उन्होंने साइंस एंड टेक्नोलॉजी इकोसिस्टम की तरफ फोकस किया कि साइंस टेक्नोलॉजी इनोवेशन में आर्टिफिशियल इंटेलिजेंस इकोसिस्टम क्या है। एवरीबडी, अगर मैं आपसे पूछूं कि इकोसिस्टम क्या है तो सबके अपने अपने व्यूज़ होंगे यहाँ पे कि व्हाट इज़ द इकोसिस्टम। म्यूट कर लीजिए। आर्टिफिशियल इंटेलिजेंस इकोसिस्टम क्या है, क्या हो सकता है, कोई अंदाज़ा लगा कर देख सकते हैं इसको कि क्या हम बोलने जा रहे हैं। हम वैसे इकोसिस्टम की बात कर रहे हैं जो आर्टिफिशियल इंटेलिजेंस रिलेटेड है, यानी एक सिस्टम डेवलपमेंट, जिस सिस्टम को डेवलप करने के लिए हमें जो रिक्वायरमेंट होती हैं और जो रिसोर्सेज होते हैं उन सारे का कलेक्शन, कॉम्बिनेशन, उन सारे के कंपोनेंट्स का जो एक सार है वो हमारा होता है AI इकोसिस्टम। सो व्हाट इज़ देयर, लेट्स सी। AI ecosystem is basically nothing. It's a collection of these tools, technologies, stakeholders, processes. और इससे हमारा इकोसिस्टम बनता है जिससे हम डेवलप, डिप्लॉय और मेंटेन करते हैं AI सिस्टम को। तो इकोसिस्टम का मतलब यहाँ पे वो हमारा एनवायरमेंटल इकोसिस्टम नहीं है, AI आर्टिफिशियल इंटेलिजेंस इकोसिस्टम से है। और आर्टिफिशियल इंटेलिजेंस इकोसिस्टम में हम जिस AI सिस्टम को डेवलप कर रहे होते हैं, बना रहे होते हैं, डिप्लॉय कर रहे होते हैं, उसमें क्या क्या टूल्स, टेक्नोलॉजी, कौन कौन स्टेक होल्डर्स आएंगे, वहाँ पे हमारे एथिक्स क्या होंगे, वहाँ पे प्रोटोकॉल्स क्या होंगे, वो सारी चीज़ों की जानकारियाँ और क्या प्रोसेसेस उसमें इन्वॉल्व होंगे, उससे हमारा AI इकोसिस्टम बनता है। What are the things which are needed to develop this kind of AI ecosystem? So hardware requirement, everybody knows about this, that hardware is required to execute, to perform this. Software is required to perform this. Data, obviously we had a talk related to data yesterday. Infrastructure, human expertise. This means what? Ki we need all such things to develop AI ecosystem. Right? And then that AI ecosystem is dynamic, which gives us good results. Okay? So this is the story behind this AI ecosystem, and the tools and technologies which are needed to develop this particular thing are divided in four categories. These are the components: models, frameworks, hardware, cloud platforms. Yesterday, Dr. Chandrasekhar Azad explained about the models, frameworks, hardware, even cloud platforms. So see what are there in the models. You all are aware of this: machine learning, deep learning, natural language processing and computer vision. मशीन लर्निंग की बात कल कर रहे थे सर, और बहुत सारे एल्गोरिदम्स को भी बताया उन्होंने, कैसे उसे एग्जीक्यूट कराना है, कैसे ट्रेन करना है, कैसे टेस्ट करना है। डीप लर्निंग थी, न्यूरल नेटवर्क, कॉन्वोल्यूशन न्यूरल नेटवर्क की बात हुई, ठीक है। नेचुरल लैंग्वेज प्रोसेसिंग जो हम चैटबॉट बनाने के लिए यूज़ करेंगे, ठीक है। और कंप्यूटर विजन जहाँ पे हम इमेज डेटा सेट को यूज़ करते हैं और उस इमेज डेटा सेट से हम इमेज पे कई चीज़ों को परफॉर्म कर सकते हैं। लाइक वन ऑफ द टॉपिक इज़ इमेज सेगमेंटेशन। ओके, व्हाट आर द फ्रेमवर्क्स नीडेड फॉर दैट? दे आर द टेंसरफ्लो, पाईटॉर्च, साइकिट लर्न, पाइथन में यूज़ होते हैं। आपको ये सारे अभी जितनी भी चीज़ें हैं वो डीप में अभी मैं नहीं बता पा रही हूँ, लेकिन आगे अभी आप देखेंगे, मैं एग्जाम्पल दूंगी आपको फ्रेमवर्क्स के बारे में। देन हार्डवेयर, GPU, TPU, CPU इवन, ठीक है। और क्लाउड प्लेटफॉर्म्स जो होते हैं लाइक AWS, गूगल क्लाउड, माइक्रोसॉफ्ट एज्योर, जो क्लाउड कंप्यूटिंग में हमारे यहाँ के जो स्टूडेंट पढ़ रहे होंगे, क्लाउड कंप्यूटिंग एक टॉपिक है उनका, उसमें इन सारी चीज़ों को उन्होंने पढ़ा है और उनको इस बारे में आइडिया है कि गूगल क्लाउड और माइक्रोसॉफ्ट एज्योर क्या है और हम उसमें कैसे काम कर सकते हैं। डेटा इंफ्रास्ट्रक्चर क्या है? द डेटा कलेक्शन। कल हमें एक क्वेश्चन भी सॉल्व किया था सर ने, डॉक्टर चंद्रशेखर आज़ाद ने, कि डेटा कलेक्शन के लिए हम कहाँ से डेटा को कलेक्ट कर सकते हैं। तो डेटा कलेक्शन के लिए उन्होंने एक UCI बताया था, आप लोगों को याद होगा। वहाँ से भी हम डेटा कलेक्ट, और बहुत सारे ऐसे साइट्स हैं, ओपन सोर्स हैं, जहाँ से हम डेटा ले सकते हैं। बट सिंथेटिक डेटा भी जनरेट किया जा सकता है। अगर हमको लगता है कि हम AI को बना रहे हैं और कुछ डेटा जो मुझे रिक्वायर्ड है और मुझे मिल नहीं रहा है, तो हम सिंथेटिक डेटा भी बना सकते हैं जो मिमिक करेगा हमारे ओरिजिनल डेटा की तरह, और टेस्टिंग के लिए काफ़ी होता है। एंड देन उसके बाद हम उसको इम्प्लीमेंटेशन बेस पर जब लेके जाते हैं तो ओरिजिनल डेटा से फिर वहाँ पे हम टेस्ट कर सकते हैं। So generate synthetic data and open source you can use for the data collection. Now the data storage, you know, the databases, data lakes, जो data collection है, data storage जहाँ हम data को रखते हैं, वो databases use होते हैं हमारे storage purpose के लिए. And the data pre-processing, like एक क्वेश्चन था कि डेटा जो भी आता है उसमें रिडंडेंट डेटा भी होते हैं, उसमें फेक डेटा भी होते हैं, उसमें बहुत तरह के डेटा ऐसे होते हैं जिनको लेके हम टेस्ट नहीं कर सकते. तो इसका मतलब क्या हुआ कि वैसे डेटा को प्री प्रोसेस करना ज़रूरी होता है, क्लीनिंग की ज़रूरत पड़ती है, और प्री प्रोसेसिंग करने के बाद जब डेटा हम लेकर जाते हैं तो उसको अपने मुताबिक फिर हम ट्रेन करते हैं. सो नाउ एआई कंपोनेंट्स में ह्यूमन एक्सपर्टीज़ कहाँ पे आते हैं? तो डेटा साइंटिस्ट एंड इंजीनियर्स, डोमेन एक्सपर्ट्स, एथिसिस्ट्स एंड these are the users or you can say stakeholders जो इन्वॉल्व होते हैं. और एक्सपर्टीज़ की तो ज़रूरत है ही. अगर हम कोई बड़ा टास्क करने जा रहे हैं, कुछ अच्छे सॉफ्टवेयर को डेवलप करने जा रहे हैं, तो एक टीम की रिक्वायरमेंट होती है, जिस टीम में सारे लोग बैठ करके इस चीज़ को डिस्कस करते हैं कि जो हमारा सिस्टम डेवलप होने वाला है वो सिस्टम का आउटपुट कैसा होगा, उस सिस्टम से हम लोग क्या देने वाले हैं लोगों को. सो एआई इकोसिस्टम के एप्लीकेशंस भी आप लोगों को मालूम है कि हम लोग चैटबॉट बना सकते हैं, ऑटोनोमस व्हीकल्स हैं हमारे पास, रिकमेंडेशन सिस्टम्स एंड प्रेडिक्टिव एनालिटिक्स कर सकते हैं. अभी मुझे कोई स्टूडेंट बताएगा प्रेडिक्टिव एनालिटिक्स का कहाँ पे यूज़ हो रहा है जो आप देखते हैं लाइव? हाँ बताइए. ओके, और भी कुछ? क्रिकेट देखते हो? शेयर मार्केट, यस सर, राइट. क्रिकेट में भी कुछ सर स्कोर का अंदाज़ा लगाया जा सकता है, ऐसा कुछ है? क्या होना पड़ेगा? वेरी गुड सर. सो दीज आर द थिंग्स वेयर प्रेडिक्टिव एनालिटिक्स इज इन्वॉल्व. प्रेडिक्टिव मीन्स व्हाट? हम प्रेडिक्ट कर सकते हैं. कैसे? लेकिन कैसे प्रेडिक्ट कर सकते हैं? उसके लिए कोई डेटा चाहिए हमें. हिस्टोरिकल डेटा की ज़रूरत होती है. किसी चीज़ को प्रेडिक्ट करने के लिए भी हिस्टोरिकल डेटा की ज़रूरत होती है, और उससे हम आगे का प्लान आउट समझ पाते हैं. इसके लिए भी आर्टिफिशियल इंटेलिजेंस को इन्वॉल्व किया गया कि वो एल्गोरिदम्स को यूज़ करके उस चीज़ को प्रेडिक्ट कर पाए. तो सारे एल्गोरिदम्स हैं, टफ एल्गोरिदम्स जिससे लिखे जाते हैं, और कुछ यहाँ हमारे पास ओपन सोर्स में अवेलेबल भी हैं. Challenges in building an AI ecosystem. We all know this. The students are facing lot of problems. किसी चीज़ को build करने के लिए proper knowledge नहीं है अगर, तो you cannot build. And difficulty in accessing quality data. जैसे हम data के बारे में बात कर रहे थे, तो हमें synthetic data generate करना पड़ता है जब हम किसी चीज़ को test करते हैं, या फिर open source में जो available data है हम उसे use कर सकते हैं. तो जो quality data है जिसकी requirement हमें होती है, जो किसी रिसर्चर को ज़रूरत होती है, तो एप्लीकेशन पुटअप करते हैं कि हमें डेटा चाहिए आपके यहाँ का जो ओरिजिनल होता है, जो टेस्टेड होता है. वो डेटा अगर हमें मिलता है कि हाँ ये ओरिजिनल डेटा है, तो हम उस पर क्वालिटी डेटा पे टेस्ट करते हैं, तो हमारा जो भी हम सिस्टम बना रहे हैं वो प्रॉपर बनेगा. देन बायस, फेयरनेस एंड अकाउंटेबिलिटी इन एआई सिस्टम्स. ओके, स्केलेबिलिटी इन हाई इंफ्रास्ट्रक्चर कॉस्ट, ये सब कुछ है. हाई इंफ्रास्ट्रक्चर कॉस्ट, इसे माइंड करना थोड़ा. कंप्लाइंग विद इमर्जिंग लॉज एंड स्टैंडर्ड्स, आपको सारे रूल्स एंड रेगुलेशंस जो किसी चीज़ को डेवलप करने के लिए बनाए जाते हैं, प्रोटोकॉल्स, जैसे ISO सर्टिफाइड होना चाहिए, उसमें क्या क्या नियम है, उन शर्तों को लेते हुए हमें AI इकोसिस्टम को बनाना है. और AI, जैसा कि एक क्वेश्चन था कि AI ह्यूमन को रिप्लेस कर सकता है, इस पर भी सोचना है. तो AI को डेवलप करने से पहले बहुत सारे चैलेंजेस ऐसे हैं क्या, लेकिन बेनिफिट्स बहुत हैं, तो हमें AI के बिना हम चल भी नहीं सकते हैं. तो बेनिफिट्स ऑफ अ रोबस्ट AI इकोसिस्टम क्या है? देखिए, AI इनोवेशन एक्सेलरेटर आपको एक्सेलरेट कराता है नई नई आइडियाज़ को लेकर. आप जो भी आइडियाज़ लेकर आते हैं, जैसा VC साहब ने भी कहा कि हमारे यहाँ के स्टूडेंट्स पे फोकस करना कि वो जो न्यू जनरेशन है उनके पास आइडियाज़ बहुत है. टेक द आइडियाज़ फ्रॉम द स्टूडेंट्स एंड वर्क ऑन दैट. जो एक्सपर्टीज़ हैं वो आइडियाज़ पे वर्क करते हैं और उस को हम एक्सेलरेट करते हैं. देन इकोनॉमिक ग्रोथ, इम्प्रूव डिसीजन मेकिंग एंड एड्रेसिंग ग्लोबल चैलेंजेस. These are the benefits of robust AI ecosystem. So we have to use this particular AI for the use, for the proper applications. So this is the practice time now because the students want to learn something from me. So I thought I should give this practice time session to them. So what we need to develop an AI project? Whatever is written here is correct or not? Integrated development environment. बहुत सारे बच्चों ने कल कहा मुझे कि मैम किस चीज़ पे हम AI को बनाएं, क्या सिर्फ हम पाइथन से बना सकते हैं या कुछ और भी चीज़ें हैं ऐसा जो डेवलपमेंट के लिए ज़रूरी होती हैं. सो इंटीग्रेटेड डेवलपमेंट एनवायरनमेंट आपको चाहिए होता है. AI को डेवलप करने के लिए। तो आज हम यहाँ पे देखेंगे कि अगर हमारे पास कुछ नहीं भी है तो हम क्या कर सकते हैं। इफ़ वी डोंट हैव एनीथिंग इन माई सिस्टम, तो क्या हम AI बना सकते हैं। देन व्हाट फ्रेमवर्क टू यूज़। तो यहाँ मैंने एक टेंसर फ्लो जो आपको वहाँ दिखाया था स्लाइड में, वो यूज़ किया है। वो क्या है, एक ओपन सोर्स मशीन लर्निंग फ्रेमवर्क है जो गूगल ब्रेन ने डेवलप किया था और गूगल ही मेंटेन करते हैं। और ये बिल्ड, ट्रेन एंड डिप्लॉय मशीन लर्निंग एंड डीप लर्निंग मॉडल्स के लिए इस्तेमाल किए जाते हैं, जो आप पाइथन में कोड में आप इसको देखेंगे कि जब हम वहाँ पे इंपोर्ट करते हैं तो टेंसर फ्लो को लेकर हम लोग इस काम को प्रोसीड करते हैं। रन टाइम एनवायरनमेंट की ज़रूरत पड़ती है, CPU, GPU, TPU, जिस पे कल बात भी हो रही थी। GPU पे आप क्या करते हैं, CPU हमारा रन टाइम जो एनवायरनमेंट हमारे सिस्टम में होता है। और इन सारी चीज़ों को लेकर हम एक AI को डेवलप कर सकते हैं। तो दिस इज़ नॉट अ टाइम टू से थैंक यू, बी विथ मी। हम चलते हैं एक छोटा सा चैट बॉट बनाने के लिए। आर यू रेडी फॉर दैट? As per the students' demand, I first tell you where you have to go. Infrastructure. जैसा मैं बात की, तो किसी के भी सिस्टम पे AI चैट बॉट बनाने के लिए क्या चीज़ की रिक्वायरमेंट होगी, उसको देखने की कोई ज़रूरत नहीं पड़ती है। आज का वर्ल्ड हमारा इंटरनेट है। क्लाउड मीन्स इंटरनेट। इंटरनेट पे बहुत सारी चीज़ें हैं और एक छोटा सा चैट बॉट जो आज इस सेशन में आप सीख सकते हैं, बहुत ईजी सीख सकते हैं, उसके लिए कोई बहुत नॉलेज की ज़रूरत भी नहीं है। ठीक है, तो हम आज के सेशन में एक गूगल का डायलॉग फ्लो, देखिए आप यहाँ पे dialogflow.cloud.google.com, यू कैन नोट इट डाउन। आप इससे भी एक चैट बॉट डेवलप कर सकते हैं। तो जैसे मैंने कहा कि आपको डेवलप करना है, डिप्लॉय भी करना है। एक चैट बॉट को डिप्लॉय भी करना है। आखिर वो चैट बॉट वर्किंग मोड में तो होना चाहिए ना। आप सिर्फ कोड लिख लेंगे, डेवलप कर लेंगे तो उससे हमारा नहीं होगा। हमारे पास में एक, आपको मैं गूगल का ही बताऊंगी बहुत सारा कुछ इसके बाद। एक तो यहाँ पे देखते हैं कि डायलॉग फ्लो एसेंशियल्स क्या हैं। तो एक एजेंट क्रिएट करना होता है, जिस एजेंट किसको कहते हैं, जो हमारा चैट बॉट का नाम होगा, पर्टिकुलर एजेंट, उसके नाम से है ये। तो जो कीवर्ड्स इसमें यूज़ हो रहे हैं उस पर फोकस कीजिएगा। तो एक एजेंट का नाम हम यहाँ पे कुछ दे सकते हैं। आप अपने एजेंट का नाम दे सकते हैं। आप इवन मोबाइल पे भी इसको एग्जीक्यूट कर सकते हैं चाहेंगे तो। छोटा सा एक दो हम ट्रेन कर सकते हैं इसमें क्वेश्चंस। सो एजेंट का नाम हम क्या दे बताइए। AI वर्कशॉप हमारे पास है ऑलरेडी। AI फॉर स्टूडेंट्स, राइट। ये बताने की जरूरत नहीं पड़ेगी कि अंडरस्कोर क्यों डाला है। वेरिएबल नेमिंग कन्वेंशन रूल्स आप लोगों को मालूम है, रूल्स यू हैव टू फॉलो। इफ यू आर ज्वाइनिंग मोर देन वन वर्ड, देन वी हैव टू यूज द कनेक्टर। ओके, सो क्रिएट द एजेंट। This will take a little time. This is just for the beginner. उसके बाद इसके अंदर काफ़ी कुछ एक्सप्लोर करने के लिए आप एक्सप्लोर कर सकते हैं उसे। So here we are. Now see, automatically it goes to intents. Now what are the intents means? Intents are the questions which we have to frame to just make the chatbot expert to answer your questions. Okay, so intents needs the keywords. This is a natural language processing example. Intents needs the keywords. What keywords? Yesterday I told you the keywords which should be specific for each intent here. Okay, so suppose if I am writing about, yesterday we had written about AKP, about JCSTI. Okay, so about is a common word, so you have to put some of the keywords which should be unique. Okay, so one intent we have to create. So create intent. So here you will get many things. Students अभी भी आ रहे हैं. First you see the context, add context. Now see, add input context. What is your context? Good morning, suppose. सो चैटबॉट का आंसर क्या होना चाहिए? क्या हम उसे रिप्लेस कर सकते हैं अपने अनुसार से? बोलिए। एक्शन एंड पैरामीटर्स, आप जब इसमें जाएंगे तो आप एक्शन एंड पैरामीटर्स सेट कर सकते हैं और रिस्पॉन्सेज यहाँ से आप ऐड करेंगे जहाँ रिस्पॉन्सेज दिया हुआ है. तो आप ग्रेजुअली यू कैन मूव एंड यू कैन सी व्हाट आर द थिंग्स प्रेजेंट हियर. सो हम लोग दो चीज़ों को ले रहे हैं. टेक्स्ट रिस्पॉन्स यहाँ से जनरेट करते हैं रिस्पॉन्सेज से. सो गुड मॉर्निंग, what can I do for you? This is a simple question I can frame like a response, and this is saved. Okay, intent name we have to give. So suppose good morning I am giving. Intent name should be meaningful for what purpose we are creating this particular thing. So now I am switching to the, in this way we can create the intents, okay. I am switching to the particular agent first. Wait a minute, this takes some time. वो टाइम लेगा, आप यहाँ पे देखो इसे. These are the intents which are created already, okay. So creation is taking time. So see here, about JCSTI, about AKP, about principal, whatever I have already fed in this one. So see the events. Training phrases are this: JCSTI, about JCSTI, tell me about JCSTI. So training phrases should be like this, and then responses you can generate according to you. Like these are the text responses, okay. So in this way you can create the intents. After creating this intent, there is an integration part. You can test from here. देखिए, अगर आपने कोई इंटेंट बनाया है तो आप उसको यहाँ पे टेम्पररीली टेस्ट कर सकते हैं कि वेदर इट इज़ वर्किंग फाइन, गिविंग द राइट आंसर्स और नॉट, ओके. आफ्टर दैट यू कैन गो टू द इंटीग्रेशन पार्ट. आफ्टर क्रिएटिंग दिस पर्टिकुलर इंटेंट, द क्वेश्चंस you can feed whatever question you want to feed, okay. Then here the options are given. In this option I had selected this Telegram, okay. So Telegram is asking for the Telegram token, okay. So this is my Telegram token. From where I got this is the question. So go to the Telegram, everyone is having the Telegram. Go to the Telegram and just write down bot father. Write down please, this you can do, bot father. There is a ready-made bot father which is used to deploy your particular chatbot. Bot father, BOT, bot father is a single word. Now see, if you are writing, this is the assistant again. If you are writing how to start a bot, you write down how to start a bot. I will take you to this point, okay? How to start a bot. You will get the answers, means you will get the tags, different tags to start the chatbot. How to start bot? So now see, you got the answers? How to start bot? Backslash new bot is there to create a new bot. Backslash my bots are there to just edit your bots. Are you able to see? Yeah. So to create a new bot, what you have to give? What is the instruction? Backslash new bot, right? Now you just give backslash start. Is there anything? No. जब तक हम उसको डिप्लॉय नहीं करेंगे, चैटबॉट का ये नंबर वहाँ पे नहीं आएगा, कोड नहीं आएगा, तब तक हम उसे स्टार्ट नहीं कर पाएंगे. What message you are getting? Backslash start if you are putting, what message you are getting? Yeah. You got the token number? Right. So all the instructions are given over there. So you got the backslash new bot if you are writing. All right, a new bot. How we are going to call it? कल आपने देखा था ना कि AI वर्कशॉप बॉट एक लिखा हुआ था और AI AKP AI बॉट लिखा हुआ था. तो इसके लिए आपको टेलीग्राम में एक न्यू नेम जनरेट करना पड़ता है अपने बॉट का. तो आप उस बॉट का नेमिंग यहाँ पे कर सकते हैं. तो मैंने दिया था AKP_AI_bot. So now you will get the message. Good. Now let's choose a user name for your bot, and it must end in bot. That is why वहाँ पे AI वर्कशॉप का जो बॉट आता है QR कोड बनाइएगा तो वो नाम आता है. तो आपको वो बता रही हूँ कि वो गलत नहीं है. इसके नाम में नेमिंग में आपको लास्ट में बॉट देना है. ठीक है. Then you will get the message done. You got the message? Students, I want the answers from your side. You got the answer done. Congratulations on your new bot. Did you get it? So here what you see, in the second paragraph you see, use this token to access the HTTP API, application programming interface. One interface code is needed to deploy this particular bot. So the number which is written, you have to put here in the Telegram token, right? The number starts from after the colon, HTTP API colon, and the code is written over there. That code you have to write down here. The bot which you are going to create, okay? Now keep your tokens secure and store it safely. The particular message will be given. And now what you have to do, if you are putting the code here and you are starting from here, then it will be deployed to your Telegram. Got the idea? I am not starting it again. So this is integrated with the Telegram platform. There are several platforms given where you can deploy your app. Yes, definitely. You can explore and do. Okay. But the WhatsApp is not provided in the Google integration. There are the limitations. See, these are the open source, Twitter, Skype, but there is no WhatsApp option is given here. Okay. So Telegram is there. So after doing this, what you have to do, you have to just give the command, that is \start in the Telegram, and your bot will be ready. If you want to set up a new picture, you tell me. I just want a response from your side. Suppose I want to put a picture for my bot, then how we will do? You got all the commands, no? You check it? You check and tell me what command is needed to change the picture of the bot? Set user pic, right? So \set user pic, If you are putting this, you will change the picture, whatever change, this will ask the picture to provide. So you have to provide the picture and this will change the bot picture. Got the idea? So if you are having more than one bot, the option will be provided, check the bot to change the picture. So this is a very small and handy project. See, chatbot सारे स्टूडेंट्स का ड्रीम होता है कि एक छोटा सा चैटबॉट मेरा अपना हो, मैं बनाऊं उसे, और बहुत लोगों ने कल ट्राई भी किया है. मैं पर्सनली भी बहुत स्टूडेंट को रीच की हूँ कि उन्होंने ट्राई किया है, उन्होंने कोशिश की है. तो अभी मुझे लगता है कि आप इस तरह से एक छोटा सा चैटबॉट बना सकेंगे. Am I right? So you have noted it down, how to create this? See, this is the platform. This is the environment. Okay? So from here you have to create so many things related to this particular options given. The options are many. You can explore and you can put your questions. Logical question even you can build from here. Conditions you can apply, but this is a simple step to create a new chatbot. Now explore and do it by your own. Got the idea? So at least deployment of the bot is necessary, which is required, which is not known by everyone. So these are the simple steps. With the help of this, you can create your bot. I hope it is useful for you. इस तरह के बहुत सारे प्लेटफॉर्म हमें मिलते हैं जहाँ पे आप AI का डेवलपमेंट कर सकते हैं. इवन मैं आपको बता दूं कि जो मशीन लर्निंग से रिलेटेड एल्गोरिदम है, पाइथन कोड है, अगर आपके पास कुछ भी नहीं है तो आपके पास द वर्ल्ड इज़ योर्स विद दिस इंटरनेट. आप वहाँ पे जाकर क्या क्या प्लेटफॉर्म पे हम किसी चीज़ को रन कर सकते हैं, एग्जीक्यूट कर सकते हैं, उसको एक्सप्लोर कर सकते हैं, और आप एक सिंपल सा अपना आर्टिफिशियल इंटेलिजेंस रिलेटेड इकोसिस्टम रेडी कर सकते हैं. थैंक यू सो मच. स्टूडेंट्स से मैं एक्सपेक्ट करूँगी कि अभी आपके पास जो भी टाइम है, हमारे पास इंडस्ट्री से पर्सन आ रहे हैं, रिसोर्स पर्सन, जो आप लोगों को और भी बहुत कुछ बताएंगे, क्योंकि वो लोग सारी चीज़ों को इम्प्लीमेंट करते हैं, वहाँ पे एग्जीक्यूट करते हैं, बनाते हैं, ऑटोमेट करते हैं. तो आप लोगों को बहुत सारी जानकारियाँ अभी दी जाएंगी, तो आप उनसे भी बहुत सारे सवाल पूछ सकते हैं कि जिन थ्योरी को आपने पढ़ा है या सीखा है कल के सेशंस में, उनको कैसे इम्प्लीमेंट किया जाए. सो ही कैन गाइड यू.
Any query from audience?
एक घंटे के अंदर you try this bot. 1 or 2 questions, at least you can train. किसी का भी एक नया बॉट बनेगा तो अच्छा होगा, वैलिडिटी सेशन में मैं उसे दिखा सकूंगी कि बच्चे ने बनाया यहाँ पे. आप देखिए, आप एक बेस्ट फिट को आप जानते हैं कि यूज़र पिक का डायमेंशन आप कैसे दे सकते हैं. आप प्रोफाइल फ़ोटो लगाते हैं अपनी कहीं पे भी, नहीं इनवैलिड नहीं बताएगा सर. आप उस पर काम कर चुके हैं, आप व्हाट्सएप की पिक्चर को भी देते हैं सर वहाँ पे. ओके, लेट मी चेक व्हाट इज़ द डायमेंशन ऑफ दैट पर्टिकुलर थिंग. That is the big dimension picture. So this will not fit, so you have to be careful about this one. You reduce the dimension and try this. Exactly.
Good morning to all of you. That was an interesting session learning about how to create a chatbot. So I want about 5 volunteers from students. Anybody who's willing to volunteer themselves? कोई भी 5. कोई भी 5 पीछे से जिन्होंने चैटबॉट समझा हो. Okay, now let me further specify 3 from boys and 3 from girls. ठीक. Need 2 volunteers from faculties. Good. Ehsan sahab or Irfan sahab, aap. So why I'm asking this is that the Honorable VC, Jharkhand University of Technology, was at IIT ISM. So he called up and he said that he will be dropping in this institute any day and he would like to understand what the students have taken from this. So my request to Akhtar Saab and Irfan Saab is that please form a team of 5 to 6 students and develop a chat. So what I mean to say is that one of the primemost thing is that when people are not able to access your institute, they access your website, and your website should be up to date and it should be really eye-catching. So this is one of the things that I thought that it might help you all, and I hope I've already discussed with Yasin sir that we should try to go paperless. This is my personal desire, my ambition, and it's a task which I have given to the computer science department, that in the long run we should try to go paperless. Right from your requisition to your leave application to your attendance, everything, to your salary, wage, everything should be online and it should be accessible at the click of a button. So might be that this chatbot or WhatsApp bot will be a step into the direction. So please do meet me after the session, and both of you, and do let me know your timeline. Thank you. Yeah. Okay, please, you can give your name to Mr. Akhtar sir and Mr. Irfan sir, okay? So please work on that. Thank you. So this is what I want. I want your names to keep on coming. Der sahi sahi, main aaya to hai na. So a big round of applause for these two guys.
बहुत बहुत धन्यवाद डॉक्टर चंदना कुमारी. आपने AI एंड इकोसिस्टम पर अपना वक्तव्य प्रस्तुत किया और साथ ही हाउ टू क्रिएट चैटबॉट ये अपने प्रेजेंटेशन के माध्यम से बताया. आज हमारे बीच इस कार्यशाला के दूसरे दिन आज के प्रमुख प्रवक्ता श्रीमान कुमार गौरव, टाटा स्टील, यहाँ उपस्थित हो चुके हैं. तो मैं चाहूँगी कि आप सभी तालियों की गड़गड़ाहट के साथ उनका स्वागत करें. इनके स्वागत के लिए मैं प्राचार्य महोदय से अनुरोध करती हूँ कि हमारे अतिथि साहब का स्वागत पुष्पगुच्छ, शॉल एवं स्मृति चिन्ह प्रदान कर करें. डॉक्टर चंदना कुमारी, आप कृपया आए मंच के पास. हमारे बीच श्रीमान कुमार गौरव आज इस कार्यशाला के दूसरे दिन अपना वक्तव्य देंगे, जिसका विषय है इंट्रोडक्शन टू AI. हम सभी आपकी उपस्थिति पाकर धन्य हैं सर. अल कबीर पॉलिटेक्निक आपका इस सभागार में स्वागत करता है. मैं श्रीमती महनाज आफरीन से निवेदन करती हूं कि हमारे प्रवक्ता का परिचय प्रस्तुत करें.
Good morning, ladies and gentlemen. We welcome you, sir. Mr. Kumar Gaurav is a seasoned senior manager of data science and automation at Tata Steel Limited, with over 7 years of experience in delivering and maintaining enterprise AI applications. He has worked extensively with both structured and unstructured data across diverse domains, including aeronautics, industrial capital markets, FMCG, political consulting, and smart manufacturing 4.0. Notably, he was part of Honorable PM Narendra Modi's BJP Central Analytics team in New Delhi, where he led the development of AI-powered solutions for the 2019 Indian general elections campaign. Currently, Mr. Kumar is focused on developing AI solutions in smart manufacturing, addressing areas such as process optimization, predictive maintenance, and quality control. His core expertise includes machine and deep learning, generative AI, cloud and edge computing, MLOPs, foundation models, and flow engineering. Mr. Kumar holds a BE in Mechanical Engineering from VTU Karnataka and an MBA in AI and Big Data from SP Jain, Mumbai. We welcome you, sir. We request you're present here on the stage, sir. Thank you.
हाँ ये और इंटरनेट कनेक्टिविटी
जब तक कि सर का ये सेटअप तैयार होता है, आप सबों से निवेदन है कि आप चाय का आनंद ले लें।
therefore have to transform the input text in that thanks to their parallelization power, many modern neural models can be fed with heaps of data at much higher speeds and wider context windows.
So shall I start? So good morning everyone. So today I will be taking a session on generative AI and large language models. I am sure that all of you must have heard about generative AI. These days it is in too much of trend, and wherever maybe you are watching YouTube or operating your mobile or anything, you would be coming across generative AI, or you might be seeing so many ads everywhere where people might be insisting you, or you must be reading headlines where promises are being made that generative AI will take over the world, this and that. But today, one thing I will tell you, that after attending this session, you will actually come to know what actually generative AI is, what it can do. At least you will understand the main component of generative AI, over which all of the models which you might have heard, like your chat GPT or DALI or Facebook's ka Llama or any such model, or Google ka Gemini, the core upon which all these chatbots or any kind of generative AI is built upon, you will be like knowing the core of it. And I will try to make it as simple as possible, and I will try to keep it as intuitive as possible. But my only one humble request is that session has to be interactive. It can't be one way. ठीक? So wherever you feel like doubt, you can note it down and keep it with you. And जहाँ भी मतलब आप लोगों को लगे कि कुछ question आ रहा है, maybe at the end when I finish with my presentation, you can ask the questions. ठीक है? So from that, we'll start the session. So before I start bombarding with you all with my presentation and everything, I would like to understand from the crowd that आप लोगों का generative AI को लेके क्या understanding है? Anyone, whatever your understanding is, you can let me know, so that I will get a sense of what basically the understanding of the general audience is, and from that level actually I will start taking things up. So anyone, मतलब आप लोग कोई भी बता सकते हो कि it can be anything जो भी आप समझते हो या what it is.
So the machine is trained with certain questions, and with prompt we can access those questions. That is generative AI.
Okay, good. मतलब ठीक है. That is something what it does, but ठीक है. Good. Anyone else? अच्छा, ठीक है.
So from generative AI we can create anything like artificial images or new things that is not like not exist that things.
ठीक है, ठीक है. Whatever you said, whatever ma'am said, all are like part of मतलब generative AI. So what I will try to do is I will take you step by step through what generative AI is and the building block and everything. ठीक है. I will try to keep it simple only. So generative AI बोलने से लोगों का जो सबसे पहला अगर कोई एक प्रोडक्ट है जिस पे ध्यान जाता है, so that is ChatGPT, right? So ChatGPT is nothing but a, if I tell you the exact what ChatGPT is, it is nothing more than a model which can predict a next word. That's it. That is what ChatGPT is. The kind of intelligence which you see in ChatGPT is not from the model, but the way model has been trained. ठीक है. So all these generative AI, moreover, generative AI products which are based upon large language models, especially. When I say language model, it basically consists of text and everything. So अगर आप देखिएगा तो जो चैट जीपीटी है, that is actually very advanced form of large language model. If you want to trace the formation year of generative AI and all, then you have to go back in the year 2014. Actually, Sam Altman is the owner of OpenAI. ठीक है? So he was working earlier along with his team members in Google. So Elon Musk was the person who has actually taken out bunch of people out from Google. He has financed back them, and they have opened OpenAI labs. ठीक है? So if you go to how many of over here have heard about Hugging Face? Yes. So if you go to Hugging Face, then ChatGPT, if you will track the lineage, then ChatGPT is actually GPT 3.5 in model version. Before that, there are other models also of GPT series. It is GPT 1 and 2. But why it is not much talked about? Because they don't output that intelligent answers. ठीक है? In today's lab, I think your hands-on session will be post-lunch. In that session, you yourself will execute that GPT-2 model over here, and you will deploy a solution, and you will see yourself why it is not that much famous. ठीक है? So coming back to our discussion on ChatGPT and generative AI. So what I was telling, these are if you go to the intricacies of the system, then these systems are actually very dumb. ठीक है? You would have, if थोड़ा सा टेक्निकल में जाके आपने इन सभी मॉडल्स को समझा होगा या समझने का ट्राई किया होगा, then you would have come across a word called hallucination and all. So hallucination is nothing but these model gets trapped into their own prediction. ठीक है? अभी क्या है कि ह्यूमन माइंड जो है वो दिखता बहुत सिंपल है, बट इनसाइड ह्यूमन माइंड many complex processes goes within a fraction of seconds, which is very until and unless you are not observing it, it is very difficult to acknowledge all those processes and all. ठीक है? So अभी इस सेशन में भी when I am talking to you all, then I am not just talking. ठीक है? In the back of my mind, my subconscious mind is actually planning what next word should be, then arranging the entire words sequence by sequence, then it is throwing the output. ठीक है? What these large language models do, they do just the last part of thing. They just throw the output. They don't plan and reorder things. ठीक है? So that is why they are a very dumb system, and I will show you how these systems are made intelligent. ठीक है? So these are like some of the applications which you might have come across, like in a form of chatbot or a paint box. Like ma'am, they are told that using text you can generate images, you can generate code. Now you might all have come across like GitHub Copilot or many other products which are based on already, like if any one of you over here might be using PyCharm and all for your Python development and all, then you will see that AI coding assistant would be inbuilt in that, right? Even if you, like I will show you here, if you go to Google Colab, ठीक है? So you will see that option of Gemini is already there for coding, debugging. So coding assistant is one of the use cases of your generative AI model, along with image generation or other use cases. ठीक है? Now अभी क्या है कि generative AI is also, I would like to tell you that it is not a new technology. ठीक है? It is very old. how many of you over here have used Google Translate matlab service in your life? Right, everyone. So Google Translate is in existence from 2006 or 7. That is a product of generative AI. But back then it is not that much popular as it is today. Because if I talk about any other products, your Apple ka Siri or any kind of voice assistant available in your mobile, or best is when you are texting someone or using WhatsApp, the next word suggestion which comes in your mobile, yes, it is nothing but it is keeping a context of whatever you have typed, and based on that it predicts the next word. So your generative AI large language model is doing just that, not anything much more than that. Okay? But then you will ask, why all of a sudden there is such a boom and so much of discussion happening about generative and the kind of power it has got, right? It is because in the year 2008 and 9, that time storage and compute both were expensive. Okay? You would have seen that back then people would be mostly using your Oracle DB and all for storing data and all, and most of the data which were being stored was transactional in nature, mainly tabular in nature. But if you see yourself as a human being, most of the data which resides or lies around us are basically unstructured in nature. You see it, like you're seeing, you are hearing me, these are not stored, or you are not deciphering it in a form of a table and all. Okay? So anything which is in form of table are called structured data. Anything non-tabular like image, voice, video, all these are unstructured data. Okay? So human being as an individual learn most of the thing through non-structured data or unstructured data, not through structured data. Okay? So coming back, why these models have all of a sudden taken like front seat, and recently you would be not hearing so much about your regular machine learning or your supervised ML or unsupervised ML and all of a sudden generative. This is because lots and lots of money, especially in US, is being poured in computation. Storage, they have already achieved the pinnacle. Okay? Now everyone is, if you go to, since I come from organization and enterprise, I will tell you, Oracle DB with what it used to do has come down very drastically. Okay? Now most of the people are using cloud storage like BigQuery or Microsoft ka product or AWS ka product for storing their data, because those storage solutions are already capable of handling both your structured and unstructured through single place only. So, and those are dead cheap. Dead cheap matlab dead cheap when you compare to your regular Oracle licenses and all. So storage is not an issue, compute is still an issue. Okay? So you would have seen that recently. How many of you over here track stock market? Do you track global stock market? Okay. So Nvidia you would have heard about, or as a company. Nvidia has beaten Apple, Microsoft, everyone in just 1 year. People who would have bought Nvidia last year, September, July, would have got richer this year in India if you would have invested in US. Why so? Because Nvidia is hugely investing into computation. Now, situation with Nvidia is such that their customers are government of different countries. Okay? Geopolitical wars are happening because of this. US has strictly ordered Nvidia and TSMC from Taiwan that you don't have to supply chips to computation chips to China. ठीक है? So that is the condition, because supply of high computing chips, there are very limited companies. That too GPU, especially because NVIDIA has got mastery in production and manufacturing of GPUs. And all these, like one of the audience over here has only answered that we feed these models large amount of data, right? So to process, if you go to CPU and you do all these kind of activities of training models and all, then it is, honestly speaking, it is actually not possible at all. ठीक है? And for GPU, supply demand का इतना gap है कि even with government putting pressure, NVIDIA is not able to deliver these chips. And you would have seen UAE and Saudi as a country are investing $1 trillion. ठीक है? Last year, no, or maybe this, like UAE has got an official AI company backed by government of UAE. It is called TIE, TIE. ठीक है? They have like ChatGPT and all, like Google had got Gemini. They have got their own series of model. It is called Falcon. ठीक है? Similarly, Saudi Arabia government has also ordered these advanced GPU computation chips from NVIDIA. So the most recent state of the art GPU chip is H100, ठीक है? Which can do large amount of computation. If I will show you on internet, so can you see this silicon wafer? There is a large queue among countries to take this chip, and NVIDIA is not able to supply this. So seeing all these things, like how other countries are aggressively betting for getting these chips, and these chips are actually very costly, ठीक है? Because when we talk about large language models, then their training parameters are in billions, ठीक है? Initial models, like you can see BERT and all from Google, these were small, but if you see the current state of the art models from ChatGPT, like GPT-4o, or from Google Gemini, day before yesterday they have released their Gemini 2.0, ठीक है? So those are trillion parameter model, ठीक है? By the way, for your information, human brain has got 100 trillion parameters in their brain through which neurons interact with each other. And currently state of the art best model is having somewhere around 3 to 4 trillion parameters. So you can see where they are trying to go towards. They are trying to mimic human brain, but still there is so much of gap, 4-5 trillion versus 100 trillion. But that was just for your information. So you can see that for doing computation on such a huge model and all, it is not possible on CPU and all, ठीक है? So yeah, so what I was telling, that recently government of India also has got in talk with Jensen Huang, who is CEO of NVIDIA, and recently you would all have seen that he has visited Mumbai also. He was with Mr. Mukesh Ambani, ठीक है? So it was actually a request from government of India to supply H100 chips. So in India, how they are going to work is, government is going to spend for getting the chips, and startups will pay some kind of subscription or rent amount to government of India and get these chips, because individually for companies it is just impossible to get these chips. Queue is so huge for getting these H100 chips now, ठीक है? So that was a brief background about computation and all. So recently what has happened, computation has, matlab, exponentially it has increased in power. So that is why they can do more of experimentation, and so much of money is getting poured into R&D of generative AI. That is why every day you are listening and coming across so much of generative AI products, or every day, matlab, if I tell you in my field, that is AI, 1 month is equivalent to 5 years or 6 years of other technologies. 1 month, I'm telling. I will show you for your instance. This is actually Hugging Face, ठीक है? मतलब this is actually repository where all models are being kept at, ठीक है? So can you see the number of models here? The count. It is 1.2 million. ठीक है? This is what? Month of December. In month of September, there were around 4 to 5 lakh models. 4 to 5 lakhs. It has doubled in just 3 months. I'm telling you, after this session, you just keep tracking it every week or every 15 days. You will see the rise number of models. Because that is how, but it is not just that people from close community or only high-end organizations are doing R&D and developing. Now there has been so much of development happening in open source community also. ठीक? And today in our hands-on session, I will take you through open source model only through which you will deploy some application. So just want to show you like how quickly world is changing. ठीक है? Now coming back to our presentation. ठीक? Yeah. So talking about these large language models, they are basically they have basically got mastered into two kind of tasks in which you can classify it. One is text generation. Once you have got a text generation model, then you build a chat model on top of that. You remember this concept. Okay? Chat model will be only built after a text generation model will be built. And text generation model is nothing but a foundation model. Okay? So GPT-3 is foundation model. Chat GPT is the chat model. Okay? So what I told, you prompt it, it will complete a sentence. Okay? Now if you talk about use cases and all, yeah, so these are some of the use cases of currently which people are using when we talk about large language model based generative AI solution. So maybe like when we are having, like, if you would be using Microsoft Teams for attending meeting and all. Okay? So earlier what used to happen? There will be a person responsible for making MOM, minutes of meeting. Now after meeting gets over, a concise MOM gets created automatically. How it is happening? Your entire conversation is being tracked. What are the key points? It is being noted down. At the end of the meeting, a concise summary of MOM is being generated automatically. Translation I have shown you only. Information retrieval. Now, when I came here, there was a discussion going on. I think sir was standing here mentioning about chatbot development and everything, right? So he mentioned there that there are so many queries coming about admissions or last date or fee related or whatever student they might be having queries which related to admission and everything, or any matter for that per se relating to your college and all. Okay? So what you can do is there is something known as RAG, retrieval augmented generation. Okay? Using this generative AI model, which what actually happens is you will have a vast amount of data. ठीक है? For example, here, let's take example of your college only. There might be huge amount of document pertaining to admission or student related documents and all. ठीक है? So if you'll ask as a human being to go and scavenge through all the documents and find out the relevant document which might answer the query of a candidate, of a new student, then it is very difficult. What you can do is you can deploy a generative AI based models like ChatGPT or any such open source models also. Now open source models are also quite powerful in terms of doing this information retrieval task. ठीक है? And during our hands-on session, please remind me, I will tell you some of the YouTube channels from where you can learn developing all this solution. It is completely based upon open source solution, so you will basically pay nothing, but you will get so many things to learn. ठीक है? So there are some really good channels which are being maintained, and it will also help you keeping up to date what is happening in this arena. ठीक है? And recently, if you draw a line over here, then this is what 2025 is going to be about. This thing. All these things have been already done by these generative AI based models and all. Now people are running, you would have heard about agents, AI agents. ठीक है? That is a new trend in generative AI. 2023 and 4 was all about this ChatGPT based new models and all. 25 will be all about building agents. Like when I say about agent, it is like specific AI solutions for a specific task. That too, not your regular supervised model or unsupervised model. It will be your regular generative AI based solution. ठीक है? Like I will show you one how these in India it has not taken that much, but in West there are already companies which are so there is a company called Torque. ठीक है? Now you might all be aware about that currently organizations are working through data centers and all. ठीक है? Data center is a place where high-end servers, all this computing storage services will be there. ठीक है? So Torque as an organization has got a product called Torque Socrates. ठीक है? It is a generative AI based AI agentic solution where, see, the AI SOC analyst, it gives you security threat in real time that is being taken control by one of your generative AI model that is custom trained. This Torque as a company has trained with their own data. Let this website get loaded, then I will show you. Now earlier there were, you might have heard about people from DevOps, right? So their major responsibility is to keep your application up in production, operationalize. ठीक है? So one of their task is also to handle real-time threat and all. Like if you exactly point out this use case, then it will come under cyber security division of your organization and all. ठीक है? Yeah. So you can see how it is working. Now there is not any cyber security human being sitting there and monitoring all your threats. These models have been specifically trained on historical threat data and all, and now you can see you have already got a product from generative AI from companies. So these, matlab, what do you call it? These are just the budding shoots. 2025, you'll see so many organizations coming with AI agent based product, because now what it has happened is, storage, I have told that they have already reached very good level and all, ठीक है? How all these models and like any model, if we talk, gets trained is, they have scraped the entire data available in your public domain. Whatever data you can think about is there in their database. They have already. So now there is already saturation in terms of data availability and all. So now they are trying to generate synthetic data and all and try to do model training, but synthetic data is not that good in representing our physical world. ठीक है? So whatever intelligence they have to build in terms of model with the current architecture has been already built. ठीक है? Now there is no data also. There, if you will see that why, like the recent model which I was talking about, GPT-4o or Gemini, all these models, internally, if like for example, GPT-4o1 model has been released recently, ठीक है? So there is not much difference about the training of the data, ठीक है? What they have done is they have changed the inner engineering. मतलब instead of giving an output very frequently, they are, before like giving the output, what they have given is, they have given a bit of time window for model to give the output. What they have done some kind of prompt engineering before letting it do the output. So what it is doing, it is breaking down the task. In the back end, it is refining its generated output, then it is ranking those outputs, then it is finally giving you whatever answers are there. Earlier it was not the case. You prompt it, it will give you an output. ठीक है? So that was about use cases and tasks. So maybe you all can keep track of AI agents and all, if you are actually looking to build or learn generative AI, or you want to build a career in generative AI and all. 2025, definitely it will be there. And talking about how does scaling of, like how does about increasing the size of model helps it, right? So it has been observed that the more number of parameters, like you can see, the initial Google bot model has 110 million parameters, and later 176 billion parameter model was there. So what it has helped that model do is learn new tasks. ठीक है? So when I think when ChatGPT came, it has I think 175 billion or somewhere around, or 350 billion parameter model or something. That was in year 2022, I think, December. All these things happened. 2024 December, 2 years down the line, 200 billion odd parameter has changed into 3 or 4 trillion model. So you can understand the kind of progress which is happening. 4 trillion. So that is like what, 10x? No, 20x increase in the number of model size. So now I have given a brief introduction about all these like kind of task it does and the kind of background. But what I would like you all to do is, rather than learning just the use cases or the kind of problem which can be solved, if you want to really sustain with the technology, or if you want to learn it for a longer period, then you learn the core technology. मतलब architecture level you should go and you should understand that technology. ठीक है? So current in AI world, the king of all AI architecture is transformer. So any model you talk about currently, it is based upon transformer. ठीक है? So this model came out in the year 2017 from Google. ठीक है? And you all can be proud of it. This model was actually developed by an Indian only, but there is not too much also in taking proud because he has developed that model in US. So now that guy is a US citizen. So that is, you all know that people here have got habit of taking pride in Sundar Pichai, Satya Nadella, but unfortunately they are not Indian citizens. They all are US citizens. So similarly, Vaswani is the person who has actually, during his, I think now he has got his own company, but that time he was working in Google DeepMind. That is actually R&D lab of Google. So there this transformer has been developed. Okay? And the paper was titled "Attention is all you need." It is still there on internet. You can go read yourself and you can see. So that was the title of paper, "Attention is all you need." So like everything has got its history, right? So before transformer, definitely all these activities of like text processing and your time series processing based model, because if you see a text generation model or your chatbot, but it is nothing but a sequential process, right? Where you take the relationship of not just the previous word, but you need to have a understanding of the long context also. Like if I say my name is Kumar Gaurav, I work in, then instead I work in Tata Steel, so that Tata Steel has to understand the context. Like if suppose I have earlier mentioned that I live in Jamshedpur and all, so it has to take all those context into picture and all. So how it was being done earlier, okay? So earlier these were being taken care by your RNN, okay? So RNN, if you would be aware about deep learning domain, then in deep learning domain there are generally different kind of model architectures are there, okay? So there is your shallow networks are there, then your regular neural networks are there, then your CNNs are there, convolution neural network, then you have got your RNN, recurrent neural network, okay? So what it basically does is, see, it will show through this slide. So taste is the word, okay? It has to predict the next word. So it is predicting tea taste. Now you can see how it can go wrong itself only, okay? So see, this is the entire sentence till here. My tea tastes great, but these two if you see these two phrases together, these are contradictory, right? With bad milk, you can't have a great tea taste, right? So what I'm telling is, it was a very sequential process, word by word by word. So if you want to process such a huge amount of data like you are doing currently, it was not possible with this architecture, okay? So before transformer, I'm not saying RNN is not relevant now. Still RNNs are there, but for text-based related activities, or recently I will tell you in computer vision-based solution also, because I work in the area of computer vision also. Transformer model is taking over there also. Like why it is called king of architecture, because it is with single model architecture you can address all kind of data. Earlier it was not the case. Like for your time series you need to have your LSTM, RNNs, ReLU networks and all. Then for your imaging you need to have your CNN networks. Now transformer is taking care of all these networks, okay? So you can see here what I was mentioning. Understanding language can be challenging. Okay? I will show you one. So this is that paper. See, attention is all you need, and you can see the name of that person, Vaswani Ashish. So he is the person who is actually. This is the architecture. I will play a video, which will like make it very simple for you all to understand this architecture. Because why I am emphasizing this architecture, because if you understand this architecture, transformer, then you can do so many hands-on use cases yourself. Just for, I'm telling, since most of you over here are students, you can build it as an open source project and you can keep it update in your resume. Okay? So what was happening earlier, as I mentioned during your RNNs, was it was very sequential process. Okay? So what transformer has helped is this: instead of taking inputs one by one, now you can insert the entire input in a single go. Okay? Maybe all these things will become much more clearer when I play the video, but to keep your understanding, just be with me and try to understand whatever I am saying. Okay? And there is also, these models scales very well. Like you increase the size of data and it will still able to figure out the long relationship among different words in your sentence. Okay? So you can see RNN was earlier till paper came in 2019, but it actually became hit in 2019 onwards, 1920. Okay? So that is why the Superman kind of thing is given for LLM over here. Okay? So now what I will do, I will play that video. There are 3 videos. Okay? It will hardly take you around 20-25 minutes, but I would like that you all pay attention to that video, because in that video this architecture will be explained, what is happening actually, because your hands-on session will be based on this only. So there, when we will be executing it, you can actually relate in this entire architecture how your inputs and everything would be getting processed. So I will play this video. Okay.
In the previous video, that is pod 0 of this series, we got introduced to the transformer neural models. We had also glided over the encoder-decoder architecture. Thanks to their parallelization power, many modern neural models can be fed with heaps of data at much higher speeds and wider context windows. But what do transformers eat anyway? In this video, we'll discuss the input that gets fed to the transformer encoder. We'll start with basic input processing, then move on to the embedding layer, and finally to a very important concept of position embeddings. Let us understand these concepts better by creating a fun dialogue completer using transformers. We feed our model the first half of thousands of incomplete movie dialogues, and it learns to complete them by generating their second halves. Let us pick one example dialogue to make things more concrete. Given my obsession with the Game of Thrones, how about we train a transformer to complete Cersei Lannister's famous dialogue, "When you play the Game of Thrones, ... So the first step towards any machine learning is input data processing. As decided, the input in our case is going to be the first half of Cersei's dialogue. However, computers don't understand English language. The only language they understand is that of matrices and numbers. We will therefore have to transform the input text in that language. So as to do that, first we take all the words present in our training data and create a vocabulary dictionary out of it. If our training data is as big as the whole Wikipedia, our vocabulary can be composed of all the words in English language. Next, we assign a numeric index next to each word. And then we pick only the words that occur in the current input text. Therefore, what gets fed into the transformers are not the English words, but their corresponding indices. Let us denote each index with the letter X. And that's it. We're done with processing the input. Next, these inputs are passed on to the next layer. That is the embedding layer. And embedding layer 2 has an index for every word in our vocabulary. And against each of those indices, a vector is attached. Initially, these vectors are filled up with random numbers. Later on, during training phase, the model updates them with values that better help them with the assigned task. Now, I've chosen word embedding size of 5 so that they fit my screen. Just to let you know, the original transformer paper, on the other hand, went with the embedding size of 521. So, what are word embeddings? Well, these are just vector representation of a given word. Each dimension of the word embedding tries to capture some linguistic feature about that word. These could be things like whether the word is verb or an entity or something else. But in reality, since the model decides these features itself during training, it can be non-trivial to find out exactly what information do each of these dimensions represent. Graphically, the values of these dimensions represent the coordinates of the given word in some hyperspace. If two words share similar linguistic features and appear in similar contexts, their embedding values are updated to become closer and closer during the training process. For example, consider these two words, play and game. Initially, their embeddings are randomly initialized, but during the course of training, they may become more and more similar since these two words often appear in similar contrast. This is when compared to the word such as caterpillar that often appears in a whole different context. And so towards the end of the training process, their graphical representation may look something like this. Hence, the embedding layer selects the embedding corresponding to the input test and passes them further on. Let's denote these embeddings by the letter E. Well, that's about it. As a recap, the embedding layer takes input indices and converts them into word embeddings. Then these get passed further on to the next layer. So let us move on to and visit the final component to be discussed in this video, the position embeddings. But why do we need them? Consider this. If a LSTM were to take up these embeddings, it would do so sequentially, one embedding at a time, which is why they're so slow. There is a positive side to this, however. Since LSTMs take the embeddings sequentially in their designated order, they know which word came first, which word came second, and so on. Transformers, on the other hand, take up all embeddings at once. Now, even though this is a huge plus and makes transformers much faster, the downside is that they lose the critical information related to word ordering. In simple words, they are not aware of which word came first in the sequence and which came last. Now, that is a problem. Here is why position information matters. Consider this piece of text. Even though she did not win the award, she was satisfied. Now consider another piece of text that contains the same words but with slightly different order. Even though she did win the award, she was not satisfied. Notice how the position of a single word not only changed the sentiment but also the meaning of the sentence. So, what do we do to bring back the word order information back to transformers without having to make them recurrent like LSTMs? For starters, how about we introduce a new set of vectors containing the position information? Let us call them the position embeddings. We can start by simply adding the word embeddings to their corresponding position embeddings and create new order-aware word embeddings. Simple enough. But what values should our position embeddings contain? How about we start by literally filling in the word position numbers? So the first position embedding has all zeros, the next has all ones, and so on. Will that work? Not really. Adding the position information like that may significantly distort the embedding information, especially those of the ones that appear later in the text. For example, if the text has 30 words, the last embedding will be added to the huge number of 30. We don't want that. What if instead we added fractions? That is, if the text is composed of 4 words, our position embeddings can simply represent word position as fractions of the total length. That way, the maximum position embedding value will never surpass 1, right? That doesn't work either. This is because making the position embeddings a function of the total text length would mean if the sentences differ in length, which they often do, they would possess different position embeddings for the same position. This may in turn confuse our model, and we don't want that either. Ideally, the position embedding values at a given position should remain the same irrespective of the text's total length or any other factor. So, what should we be doing? Well, the authors of the original Transformer paper came up with a clever idea. They used wave frequencies to capture position information. Here is how they did it. Let us take the first position embedding as an example. Therefore, the POS variable in this formula will be 0. Next, the size of the position embedding has to be the same as the word embeddings, and so it is set to be 5 and is fixed. This is represented by the letter D in our formula. The letter I here represents the indices of each of the position embedding dimensions. Now, if we plot a sinusoidal curve by varying the variable indicating word positions on the x-axis, we will get a smooth-looking curve as shown. So, let us go ahead and plot a few of our position embeddings. Now, since the height of the sine curve depends on the position on the x-axis, we can very well use the curve's height as a proxy to word positions. Since the curve height only varies between a fixed range and is not dependent on the input text length, this method can help us overcome the limitation previously discussed. There is a problem though. Note how the position embedding of the words at position 0 and 6 are exactly the same, even when ideally they should be different, since 0 and 6 are two different positions. This is where the next variable in the equation, the I, comes to the rescue. If we plot the curve again at different values of i's, we get a series of curves of different frequencies. Now, here is the idea behind having curves of different frequencies. If 2 points are close by on the curve, they will remain identical at higher frequencies too. It is only at much higher frequencies that their y-coordinates on the curve differ and you may be able to tell them apart. For points further apart, on the other hand, you should be able to start seeing them fall on different curve heights quite early on. Therefore, both the position as well as the embedding dimension can inform us of the word order. Let us make this more concrete by looking at an example. Suppose we'd like to read the position embeddings for words at positions 0 and 6. Now, if you read of the value of the position embedding at position 6 and at dimension I is equal to 4, at lower frequencies, you will find it to be exactly the same as that of P0. These will start to differ significantly as you go to dimensions corresponding to higher frequencies. And so the final vectors at each position can be very different. Now, the authors did not use only the sine curves, they used a combination of sine and cosine formula. If you want to dive deeper, there is an awesome blog reference in the video's description that explains the rationale behind using both sine and cosine curves. For this video, however, we'll skip those details. For now, all you need to know is that the authors of the original Transformer paper use alternative combination of sine and cosine curves. That is, at odd positions, they use the sine formula to get their position embeddings, and at even positions, they use the cosine formula. Here is what the position embedding curves can look like when plotted on a full scale. So as to get the value of a position embedding at a certain dimension, you can simply read it off the chart. Awesome! So now we can just go ahead and add these position embeddings to our word embeddings, and that is it. As a recap, we saw how the inputs get converted into word embeddings by the embedding layer. We then add the word order or the position information to these embeddings so as to get the position-aware word embeddings. In the next video, we will discuss the most important part of the Transformer neural models, the multi-head attention layer that utilizes the concept of self-attention. So let us fly to the next video, for it will be quite a ride.
So I hope you would have understood something from this video. और बहुत ज़्यादा हो गया था क्या? Because देखिए अगर आप सारा चीज़ जो वीडियो में बोला जा रहा है वो नहीं भी समझ में आ रहा है ना, then also it is fine. You just try to get that flow, how मतलब जैसे लैंग्वेज जो हमारा वर्ड्स है वो मॉडल में कैसे ट्रैवर्स कर रहा है, ठीक है? तो उससे क्या होगा, जब आप हैंड्स ऑन करिएगा उस वक्त आपको समझ में आएगा कि जो आप इनपुट दे रहे हैं हाउ आउटपुट के वक्त वो कैसे प्रोसेस होके आ रहा है, ठीक है? सो अगर मान लीजिए वो थोड़ा हैवी भी लग रहा है, बस आप फ्लो समझने का ट्राई करिए, ठीक है? So is it okay now if I play the next video?
In the first video, that is part 0 of the series, we had got introduced to transform.
And by the way, from first video, I forgot to mention that embedding आप लोग note कर लीजिए, that is actually a very very important concept, embedding. There are products built by Microsoft and Google in their cloud infrastructure. If you'll go GCP and Microsoft Azure, that is just dedicated to this embedding as a concept, ठीक है? So after finishing this session, maybe you yourself can explore about the concept of embedding as yourself, ठीक है? Because modern DBs, modern database are not just a keyword based search, it is semantic plus keyword. So this semantic thing is coming from concept of embedding only, right? So embedding is a very important concept. That was just for information. You can note down and keep it with you, ठीक है? Now I will start with the second video.
In part 1 of the series, we discussed the importance of word order information and introduced position embeddings. So as to understand that better, we had decided to build a fun dialogue completer using transformers and use it to complete Cersei Lannister's famous dialogue when he played the Game of Thrones. To do that, we had passed our input text to the embedding layer. We had then added the position information to our word embeddings, and the resultant position-aware embeddings were passed to the next layer. In this video, we will proceed further and discuss the most important.
In this video, if you talk about the most important part of transformer also, then this what you are going to see in this particular video, this multi-head attention, is actually the heart of the entire architecture, ठीक है? So you try to pay attention as much as possible in this video, ठीक है?
Important component of transformer neural networks, the multi-head attention layer, which, let me warn you in advance, is a powerful multi-headed beast. Let us begin by understanding, why do we need attention? Imagine I showed you this line. She faced her enemies and whispered, Dracarys. And then I ask you, which Game of Thrones character are we referring to here? To answer that question, your mind will most likely not pay equal attention to all the words in the sentence. In fact, if you've watched the show, the word Dracarys should be enough to tell you that this person is none other than Daenerys Targaryen, who says that word each time she wants her dragons to rain fire on her enemies. And so the attention mechanism helps the model to focus on important words in a given input sentence. But transformers did not steal the show using simple attention. Their weapons of choice is called self-attention. Consider this sentence. He went to the bank and learned of his empty account, after which he went to a riverbank and cried. Note how the same word bank means two different things. Here the first occurrence of the word bank is referring to a finance institution, while the second bank refers to the side of a river. So how can a model know which bank refers to what? Well, the same way we humans do. We judge the meaning of a word by paying attention to the context in which it appears. For instance, An empty account can indicate that the first occurrence of the word bank means a financial institute. The word river indicates that its second occurrence means a riverbank. Likewise, the meaning of every word can be regarded as the sum of the words it pays the most attention to. Now, the difference between simple attention and self-attention is that simple attention selectively focuses on words with respect to some external query. The more important a word is in determining the answer to that query, the more focus it is given. Self-attention, on the other hand, also takes the relationship among words within the same sentence into account. And this is the layer where attention computations happen. So let us zoom in and understand the components of the multi-head attention layer. The first component in this block are 3 linear layers. A linear layer is simply composed of a bunch of fully connected neurons without the activation function. They may serve 2 main purposes. Number 1, mapping inputs onto the outputs. Number 2, changing the dimensions of the inputs themselves. Let us make this more concrete by considering the example of a single position-aware word embedding. But first, we'll need to transpose it before we feed it to the linear layer. There you go. Each of the 5 dimensions of the embedding vector will get to the linear layer nodes as input. Note how the final output size shrunk from 5 to 3. This is because in this example, our linear layer is composed of only 3 neurons. One of many reasons why you may want to change, especially shrink the dimensions of an embedding vector, is to save on the computation cost. The larger the vector, the more operation it requires. Upon doing a little more scrutiny of the linear layer, you'll see that each node is connected to the inputs using its own set of weights. So what are these weights? Well, these are just scalar numbers that the model updates during backpropagation as it gets better and better at the downstream task, which in our case is dialogue generation. It is also important to point out that these weights are fed to the model as a matrix. Great, so we are done looking at the functionality of a single linear layer. But the transformers have 3 separate linear layers. Why is that? Turns out that each one of these layers has a special function. We call them the query, the key, and the value linear layers. This can be partially motivated by the way retrieval systems work. You often type search requests on YouTube, don't you? Let us call your request a query. Now let us assume that YouTube's search algorithm is quite simplistic. What it does is simply go through all video titles in its database. These titles can be termed as the keys. Now, so as to find the best matches, it will have to compute some sort of similarity between your query and the corresponding keys. Once the most similar key has been found, it returns the video affiliated with that key. We will call the contents of a video its value. Notice how similarity can be thought of as a proxy to attention. This is because the model returns the best video only by paying attention to the most similar video title when compared to the search query. Great, but how do we compute similarity between a query and a key? A great way to compute similarity between 2 vectors is via the cosine similarity. And since we have been dealing with a bunch of vectors anyway, why not use it? Cosine similarity varies from a range of +1 to -1. Where +1 means 2 vectors point in exactly the same direction, while -1 means they point in the opposite direction. Here is how it works. If 2 vectors point in exactly the same direction, the angle between them will be 0. And if you remember your high school trigonometry, cosine 0 is equal to 1. That is, these 2 vectors have maximum similarity. Now the cosine similarity reduces as the vectors start parting ways. And the maximum dissimilarity occurs if they point in complete opposite directions. Cosine similarity between 2 vectors can also be obtained by taking the dot product between the elements of the 2 vectors and then dividing by their magnitudes for scaling purposes. More generally, we can rewrite our equation like so. Now, if you are to compute the similarity between matrix elements instead of vectors, we'll have to transpose the second matrix to avoid conflicts in dimensions during matrix multiplications. And since we are dealing with queries and keys, let us plug those in our equation. Awesome. But how does that tie back to our attention layer? And what exactly should we feed to our query, key, and value linear layers? Well, to the query layer, we feed our position-aware embeddings. We then make 2 more copies of our embeddings and feed the same to the key and the value layers. I know, that makes no sense. Because in the YouTube example, didn't the queries and the keys and the values mean different things and had very different contents? So why then here are we using the same content as input to the query, key, and the value layers? Well, that is where the self-attention part comes into play. Let us take our 3 embedding copies and neatly put them on the side. We then pass them through each of the linear layers. And all that means is that we multiply our embedding layers with the weights of the linear layers. Note that each linear layer has its own set of weights. Since the matrix multiplication will require certain dimensions, we will have to transpose our embedding matrices accordingly. After multiplication, each linear layer outputs a new matrix. And these are called the query, the key, and the value matrices. For now, let us focus on only the query and the key matrices because remember how only the query and the keys were used in our video retrieval example to compute the similarity? We therefore first do a simple dot product between our query and the transpose of our key matrix. The output of this dot product can be called an attention filter. Since this is a very important output, let us zoom in and understand its contents. At the start of the training process, the contents of the attention filter are more or less random numbers. But once the training process is done, they take on more meaningful values. If you look closely, the scores inside this matrix are in fact attention scores. For example, let us consider the row corresponding to the word game. The highest attention a word pays is usually to itself, for it is the most similar to itself. The next highest attention score is given to the word which is the next most similar to it. In this example, that word is play. Finally, we scale our attention scores. The authors of the Attention is All You Need paper divided the score by the dimension of the key vector. In our example, that is 7. Finally, we squash our attention scores between the values of 0 and 1 using a softmax function. And we get our final attention filter. Let us take a quick recap of what we've done so far. We created 3 copies of our embeddings. We passed one of those duplicates through the value linear layer and got a value matrix. We passed the remaining embedding copies through the query and the key linear layers and scaled the results to get an attention filter. So we now have our original value matrix, which pretty much represents the original embedding information because we did not alter them much except for passing them through a single linear layer. On the other hand, we have our attention filter with attention scores that were computed using the dot product between the query and the key matrices. Alright, great. But why on earth did we go through all of this? What is the purpose of this attention filter? What is the point of this value matrix? Well, even though we are dealing with NLP, it is much easier to understand the intuition behind this using computer vision. Suppose you are Avatar Aang from the most awesome anime on the planet, Avatar: The Last Airbender. Anyhow, so you are going about doing your avatar business, that suddenly you see this. Now, if your brain were to process all the information in the frame pixel by pixel, by the time you reach just 10% of the frame, you will most likely be blasted off your skin by lightning bolts. That is because this is none other than Princess Azula of the Fire Nation, the most awesome evil princess there ever lived. Yeah, Cersei, you better be scared. And therefore, thank God that our brains work much faster. Rather than taking all the information in, they filtered out the unnecessary background information and zoom in to focus on what truly matters in that moment and in that context. And if you look closely, the final filtered image is actually a combination of two frames, an attention filter and the original image. That is, if you multiply the pixel of the attention filter with the original image, you get the filtered image with all the unnecessary details thrown away. In the same way, when we multiply our attention filter with the value matrix, we get a filtered value matrix which assigns high focus to the features that are more important. And this filtered value matrix is the final output of our multi-head attention layer. Well, almost. There is one more detail. Remember how we said that the multi-head attention is a multi-headed beast? We have currently dealt with just a single head. There are two more heads to go. So why do we need more than one head? Let us get back to our Princess Azula's example. The first filter had helped us to focus on who was in the image. But as I told you before, she's a supervillain, and so if you are the avatar, you may want to weigh your options carefully. Maybe you may also want to focus on the clear skies behind her to see if you could use some of your awesome airbending skills to blow her away. Or maybe you could also use your earthbending skills to bury her under those rocks. Similarly, Transformers don't learn one attention filter. They learn multiple, each focusing on a different linguistic phenomenon. Each attention head therefore outputs its own attention filter, which in turn outputs its own filtered value matrix, each zooming in on a different combination of linguistic features. In the original Transformers paper, the authors used a total of 8 attention heads. We will, however, stick to 3. Awesome, so what do we do next? We simply go ahead and concatenate them together. Since we don't want this vector to grow longer and longer with each head used, we pass it through a linear layer to shrink its size back to 7 by 5. And this is the final output of the multi-head attention layer. That's it. It is on.
Yes, so that was in this video. So energy बचा है और because there is one more video. मतलब सबसे कॉम्प्लेक्स वाला यही था वीडियो, दूसरा जो इसमें आप लोग को मतलब थोड़ा मैट्रिक्स और वेक्टर ये सब था. नेक्स्ट वन इज मतलब इससे तो लाइट ही है वो, बट इफ यू विल टेल देन आई विल प्ले द थर्ड वन. But if you don't want, then it is okay. मतलब ठीक है, I will just tell you what is there in that third video. But if you understand the entire flow, then maybe during your hands-on you will have a better understanding of what is happening.
Added dragons that Transformers were able to conquer the kingdom of NLP. In the third and the final part of this series, we will discuss the remaining
So, आप लोग के अंडरस्टैंडिंग के लिए जस्ट बता देते, जो पहला वीडियो था वो आपका यहाँ तक था, पोजिशनल इन कोडिंग तक. जो अभी आपने देखा वो ये वाला पार्ट है, ठीक है. तो ये जो पूरा सेक्शन है ना, इनपुट से लेके ये जो पूरा ऊपर अटेंशन तक, इसको इनकोडर बोलते हैं, ठीक है. तो आपका इनकोडर सेक्शन ख़त्म हो गया है. अभी हम लोग जो लास्ट वीडियो है उसमें इसके बारे में देखेंगे. दिस इज कॉल्ड डिकोडर, ठीक है. योर चैट जीपीटी इज दिस ओनली दिस सेक्शन, सेकंड डिकोडर मॉडल, डिकोडर बेस्ड मॉडल.
In episode 1, we discussed position embeddings in great depth. In episode 2, we rode on the back of multi-head attention and self-attention mechanisms. In this episode, which is going to be the final episode of this series, we will begin our journey by discussing residual connections and then move on to layered normalization. Our journey will end with Transformers decoder module, where we'll touch upon some essential decoder components such as the softmax and the output embedding layer. Finally, we'll finish by understanding its mass attention module. Now, if you came here for only the mass attention component, I suggest you check the timestamps in the video's description and fast forward to that time. Otherwise, let's dive straight in.
आप लोग बस फ्लो पे मतलब फोकस करिएगा, ठीक है? ये मतलब जो भी ये कॉन्सेप्ट्स वगैरह बोल रहा था, ऑल दोज आर बिट मतलब मैथ हैवी, तो शायद आप लोग का उतना रेलिवेंट भी ना हो, बट आप लोग बस फ्लो देखिएगा कि हाउ मॉडल फाइनली आउटपुट्स द वैल्यू जब हम लोग उसको प्रॉम्प्ट या ट्रिगर करते हैं तो.
Residual connections serve two main purposes: knowledge preservation and helping with the vanishing gradient problem. Let us discuss its knowledge preservation aspect. To make things more concrete, consider this small neural network composed of a bunch of neurons. During forward propagation, the inputs may get modified considerably by the time they reach the last layer. And this may result in the loss of some useful information that were present early on in the system. For example, the blue layer weights may have positional information freshly encoded, which may be forgotten by the time the information reaches the fourth layer. Now the question is, how do we make sure that the useful old information does not get lost? One solution is to add residual connections, which essentially are information highways that bypass a lot of intermediate layers and feed information to much deeper layers. We then simply add these two pieces of information and get our final layer output. This helps the deeper layer not forget important information that was present early on in the system. And from here, the forward propagation continues as usual. In summary, a residual connection is a lot like taking a shortcut, bypassing everybody else, and then getting back on the racetrack. Awesome. Let us proceed further. So we now have the output of the embedding layer that uses the highway residual connections to go on to the next layer. We also have the output of the multi-head attention component that too goes on to the next layer. So what is this next layer? Well, we call it the add and norm layer. The add part means simple addition of the two inputs that get fed to this layer, and we get a summed output. The norm or the normalization part is a bit more tricky. Let us zoom in the summed output to understand this better. As you can see, each row corresponds to a word in the sentence, and each column to features. We had discussed features in context of word embeddings in episode 1, and so feel free to go over it again just in case this is confusing. Each of the neurons activate. With that, what do you know? We have slayed the encoder concepts of transformer neural networks. The decoder mostly relies on similar concepts. In fact, there are only a handful of components that work slightly different when compared to the encoder. So join me and let's finish this off together. In general, the encoder takes in the input text and converts it into some vectorized representation. The decoder then takes this representation and converts it into new text. Now, one major difference between the encoder and the decoder is that while the encoder takes just one input, that is the source text, the decoder takes two. The first being the output of the encoder, and the second being the output text that has been generated thus far. Let us start with its first input. After we get the output of the encoder, we split it into two copies. These are the query and the key copies. Check out episode 2 for a detailed description about the query and the key value matrices. For now, let us leave these matrices up here for the time being and focus on the bottom of the decoder, which mainly deals with the generated text. We usually assume that the first word the decoder generates is a special token indicating the start of the generated sentence. We feed this token as the first input to the decoder. From here, it travels through the output embedding layer, which converts it into an embedding vector. And then, we add positional information to it and pass it on to the multi-head attention layer. Ignore the masking part from now, we will come back to it later. The output of the multi-head attention layer then goes on to the add norm layer. This gives us our value matrix. And finally, we send our value matrix to the decoder's second multi-head attention module. Now, if we zoom into this multi-head attention layer, you will see that the decoder's multi-head attention layer in fact takes three inputs. The first being the query and the key matrices that came from the encoder, and the second being the value matrix that comes from the previously generated text sequence. The multi-head attention module takes these three inputs and then works exactly the same way as was covered in episode 2. Okay, what now? The output of the multi-head attention layer flows forward. Let us pause at the final linear layer as this is kind of important. The final linear layer possesses a bunch of fully connected neurons. Now,
in this you will come to know मतलब how final जो output words वगैरह आपको मिलते हैं, how मतलब model decipher and give you the word back.
the size of this layer depends on the number of classes there are. If your classifier is supposed to distinguish dogs from cats and hence just has two classes, the final dense layer will have only 2 units. If you also want to classify, say, baby dragons, you will have to throw in another unit, and hence the size of your linear layer is going to be 3. When speaking of dialogue generation, on the other hand, the size of the final layer is the total vocabulary size, which is quite intuitive if you think about it. Text generation is in fact a classification task where every word can be considered a class on its own. For instance, if our input text is "when you play the Game of Thrones," the classifier will have to assign probabilities to each of the n words in its vocabulary. We then often choose the word with the highest probability to continue generation. The input to the final linear layer, of course, is not raw text, but the output matrix from the add and norm layer. If we send this matrix as it is, the output will be such that each unit in the final linear layer outputs a vector. Now, the problem is that we don't want vectors. What we want instead are scalar probability scores for every word, so that we could pick the word with the maximum score. To achieve that, we'll first have to flatten our matrix into a single row. We then concatenate these and pass them to the linear layer. The information is passed by each input dimension being multiplied by the next layer's parameters and then being summed together. Please check episode 2 for more details on linear layers. As a result of this, we get a single score for each word. We call these raw scores the logits. We then pass these scores into the softmax layer and get them converted into probabilities. Finally, we can choose the word with the highest probability for generation. Now that you understand the first time step, let us see how the decoding process works in its entirety. So far we saw that the decoder first consumes the encoder output. We also pass on the first generated word, which is a special token indicating the start of the generated text. This token is passed to the output embedding layer, and then the position information is added to it. Finally, we pass it onto the remaining layers and have the next word generated. We follow the same steps for this newly generated word, except now the decoder consumes both the first and the second word. And using these, we get a third word in the sequence.
Now you can see that ये जो अभी वीडियो में ये लेडी बता रही थी, how one by one your output is getting fed to the model back for generating the next word. ठीक है? So this is how basically मॉडल स्टार्ट जनरेटिंग द आउटपुट. जो आपको आउटपुट वगैरह मॉडल से दिखता है, दिस इज़ हाउ इट स्टार्ट जनरेटिंग. इसीलिए अगर मॉडल ने कहीं से भी गलत वर्ड या लाइन पकड़ना स्टार्ट किया, देन द केस ऑफ हेलुसिनेशन स्टार्ट. इट विल स्टार्ट डेविएटिंग फ्रॉम इट्स एक्चुअल असाइंड टास्क.
Till the decoder generates a special end token. Awesome. You are now ready for the last component.
So yes, मतलब और भी है, but that was more of what I wanted to show कि ये जो पूरा आर्किटेक्चर है ये काम कैसे करता है. अगर आपने ये सारे स्लाइड्स में वही सारा है जो भी आपने देखा है, जस्ट 2-3 पॉइंट्स, देन मे बी दिस स्लाइड विल गेट ओवर. ये तो वही है जो वीडियो देखने के बाद आप लोगों को कैसा लग रहा है? थोड़ा गर्मी गर्मी लग रहा है क्या? ट्रांसफार्मर मतलब एक्चुअली टू बी रियलिस्टिकली स्पीकिंग, जब भी आप जनरेटिव एआई के रोल्स के लिए इंटरव्यू के लिए बैठोगे ना, सो देयर विल बी लॉट्स एंड लॉट्स ऑफ क्वेश्चन. इफ यू आर टारगेटिंग पोजीशंस रिलेटेड टू जेन एआई डेवलपर और एनीथिंग, तो वो लोग पूछेंगे ही पूछेंगे. बिकॉज if you have got command on this architecture, then only you can उसके ऊपर आप फाइन ट्यूनिंग या कुछ भी डिफरेंट काइंड ऑफ एप्लीकेशन बिल्डअप कर पाओगे. जस्ट एक चीज दिखाना चाहते हैं, ट्रांसफार्मर में भी 3 टाइप का नेटवर्क 3 टाइप का मॉडल होता है. ठीक है. द वन इज ओनली इनकोडर. जो बर्ट मॉडल पहले गूगल का आता था ना, दैट इज जस्ट इनकोडर बेस्ड. आपने अभी दोनों का देखा, इनकोडर प्लस डिकोडर, बट यूज वो लोग केवल इनकोडर का ही करते हैं डिप्लॉयड मॉडल में. जो जीपीटी है ना, चैट जीपीटी, वो खाली ये है, डिकोडर मॉडल है. जो गूगल ट्रांसलेटर दिखाया ना आपको, वो ये है. गूगल का एक मॉडल आता है फ्लैन T5 सीरीज, फ्लैन सीरीज ऑफ मॉडल. ठीक है. वो ये दोनों इनकोडर डिकोडर सेट ऑफ मॉडल है. ठीक है. आपको फ्लैन T5 से मैं हैंड्स ऑन सेशन में यूज़ भी कराऊंगा, उसमें आप देखिएगा. ठीक है. प्रॉम्प्टिंग और प्रॉम्प्ट इंजीनियरिंग का कुछ मतलब कॉन्सेप्ट वगैरह है, बट मैम डू वी हैव टाइम और वी हैव टाइम? ठीक ठीक, 2-3 मिनट है. वॉट एवर आई कैन कवर आई. ठीक ठीक. तो ये तो मतलब ट्रांसफार्मर का आर्किटेक्चर रिलेटेड था. अभी आपने प्रॉम्प्ट और प्रॉम्प्ट इंजीनियरिंग के बारे में सुना होगा. ठीक है. तो प्रॉम्प्ट अभी क्या है, ये जो मॉडल मैंने आपको बताया, ये ह्यूज अमाउंट ऑफ डेटा पे ट्रेन हुआ है. ठीक है. सो इसको क्या है ना, ट्रिगर करना पड़ता है. ठीक है. इसको आपको जैसे इफ सपोज वी आर हैविंग अ कन्वर्सेशन, ठीक है, ऑल ऑफ अ सडन मुझे अभी इसी में से कोई पूछेगा कि इंडिया वर्सेस ऑस्ट्रेलिया टेस्ट सीरीज में अभी क्या चल रहा है. ठीक है. देन जो मेरा माइंड है वो रियल टाइम में ये कन्वर्सेशन से शिफ्ट होके उधर जाएगा. तो क्या है, मेरे माइंड को ट्रिगर करने के लिए कॉन्टेक्स्ट वो सेट कर रहा है. सो दैट इज हाउ यू बेसिकली, out of all the training and everything this model has learnt upon, you trigger this model for doing that work. Because क्या है, जैसे मैंने आपको दिखाया ना, how when you scale the model, it doesn't only learn the relationship between words, sentences and all, parallelly it learns different activities also. Like जब scrape करके आप लोग data दे रहे हो तो उसमें different kind of summarization भी है, translation भी है, and काइंड ऑफ टास्क है जिसका वो मतलब सारा रिलेशनशिप वगैरह लर्न कर रहे हैं. ठीक है. सो प्रॉम्प्ट इंजीनियरिंग इज नथिंग बट गाइडिंग योर मॉडल टू डू सम पर्टिकुलर काइंड ऑफ टास्क. ठीक है. सो उस जो प्रॉम्प्ट इंजीनियरिंग है उसमें देयर इज अ टॉपिक कॉल्ड इन कॉन्टेक्स्ट लर्निंग. ठीक है. उसमें क्या होता है, जैसे कि मान लीजिए कोई नया बच्चा है, या मान लीजिए कोई नया चीज़ है. ठीक है. जो जिसके बारे में वी आर नॉट अवेयर. सो हाउ डू वी लर्न अबाउट इट? ठीक है. वी शो दैट चाइल्ड और दैट पर्सन फ्यू एग्जाम्पल ऑफ द ऑब्जेक्ट और जो भी टॉपिक के बारे में उसे सिखाना चाहते हैं. सो दीज जनरेटिव मॉडल्स आर ऑल्सो सिमिलर इन नेचर ओनली. सो उसको जो फ्यू एग्जाम्पल्स दे के हम लोग उसको सिखाते हैं ना, द काइंड ऑफ बिहेवियर विच वी वांट आउट ऑफ दैट मॉडल, इट इज कॉल्ड इन कॉन्टेक्स्ट लर्निंग. तो उसमें क्या होता है कि एक होगा कि मॉडल अपने ट्रेनिंग के टाइम में ही कुछ एक्टिविटी सीखा होगा. ठीक है. आप उसके बेसिस में उसे वो काम कराना चाहते हैं. ठीक है. जैसे कि फॉर एग्जाम्पल वी टेक दिस, I give a statement and I ask the model to classify the sentiment. इसका sentiment क्या है? I love this movie. Human mind बहुत आराम से ये बता देगा एक पॉजिटिव सेंटिमेंट है, ठीक है. आपको क्या लग रहा है? ये मॉडल ने भी पॉजिटिव दिया है, बट इसने क्या किया है? इसने कुछ अपना रीजनिंग या पावर नहीं लगाया है, ये बस एक सेंटेंस कंप्लीट किया है, बिकॉज अपने ट्रेनिंग में इसने सेंटिमेंट के साथ ऐसा पॉजिटिव देखा होगा. While it looks to us that it is doing a very intelligent work, it is just completing this sentence. इसीलिए मैंने बोला था it is a very dumb system. हम लोगों को लगता है कि ये बहुत इंटेलिजेंट है, लेकिन है नहीं. इसने अभी मैं आपको दिखाता हूँ नेक्स्ट स्लाइड में, ठीक है. अभी इसमें देखिए सेम थिंग इज बीइंग डन. आई लव दिस मूवी, आई लव दिस मूवी सेम था. यहाँ पे इसने पॉजिटिव दिया, यहाँ पे देखिए इसने सेंटिमेंट में क्या लिखा. इट इज जस्ट ट्राइंग टू कंप्लीट दिस सेंटेंस, दैट्स इट. तो उस केस में हम लोग क्या करते हैं, हम लोग ना इसको कुछ एग्जाम्पल्स देते हैं, ठीक है. जैसे अगर आपने एक एग्जाम्पल दिया प्रॉम्प्ट इंजीनियरिंग में तो उसको 1 शॉट बोला जाता है, 2 एग्जाम्पल दिया तो 2 शॉट बोला जाता है. तो क्या होता है जनरली बिफोर वी प्लान टू फाइन ट्यून आवर मॉडल, ठीक है. फाइन ट्यूनिंग इज अ वेरी हरक्यूलियन टास्क बिकॉज यू हैव सीन the amount of data kind of compute will require to fine tune these models, ठीक है. तो हम लोग क्या होता है इसको 20, 50, 100 ऐसा एग्जाम्पल देते हैं जिसके बेसिस में वी एक्सपेक्ट दैट दिस मॉडल्स आर ऑलरेडी सो मच इनरिच विथ न्यूरॉन्स कि ये लोग ये वाला भी जो एक्टिविटी है सीख सकते हैं, बिकॉज समटाइम ड्यूरिंग देयर ट्रेनिंग ऑल दिस एग्जाम्पल्स दे वुड हैव गॉन थ्रू, और वो मतलब उससे ये लोग को रिलेट करके ये एक्टिविटी भी सीख सकते हैं. तो अभी देखिए यहाँ पे जैसे इसे एग्जाम्पल दिया जा रहा है, ठीक है. आई लव दिस मूवी, इसने बताया सेंटिमेंट पॉजिटिव है. फिर दूसरा उसे देता है आई डोंट लाइक दिस चेयर, सेंटिमेंट नेगेटिव है, ठीक है. अब ये क्या है, इस पैटर्न को देख के वो ऑल दो सेंटेंस कंप्लीशन का ही टास्क कर रहा है, ठीक है. बट अब वो ये समझ गया है कि rather than just completing and giving the gibberish output, I have to align my output according to this positive और निगेटिव सेंटिमेंट ओनली, ठीक है. अब ये पॉजिटिव निगेटिव में वो गलत आंसर दे सकता है, लेकिन अब वो क्या होगा कि इसके बियॉन्ड वो डेविएट नहीं करेगा. सो दैट इज व्हाट वी हैव डन बेसिकली. यहाँ पे 2 एग्जाम्पल दिया, तो इसको एक्चुअली फ्यू शॉट इन्फेरेंस बोलते हैं, ठीक है. तो अगर आपने प्रॉम्प्ट इंजीनियरिंग वगैरह किया होगा या मॉडल जब यूज करते होंगे तो कुछ ऐसा टास्क जो कि मॉडल ने स्पेशली लर्न नहीं किया और आप उसे करवाना चाहते हैं, तो आप क्या होता है उसे कुछ एग्जाम्पल देते हैं और एक्सपेक्ट करते हैं कि उस बेसिस में दैट मॉडल लर्न्स एंड इट स्टार्ट डूइंग द डिजायर्ड टास्क विच यू आस्क फॉर, ठीक है. ये आपने ये मैं आपको दिखा भी देता हूँ. ये एक्चुअली जब इन्फेरेंस का टाइम है, जैसे कि मॉडल ट्रेन हो गया है, ठीक है, और उसके बाद फिर आपको आउटपुट चाहिए उस मॉडल से, ठीक है. तो उसमें क्या होता है, कुछ कुछ पैरामीटर्स होते हैं, ठीक है, जो आपको सेट करना रहता है, ठीक है. तो आपने ये जो वीडियो देखा उसमें लास्ट में इसने जो दिखाया था वहाँ पे एक लीनियर लेयर में आपको दिखाया होगा कि प्रोबेबिलिटी डिस्ट्रीब्यूशन हो रहा है, राइट, जिसमें एवरी वर्ड का अपना एक प्रोबेबिलिटी स्कोर आ रहा था, राइट. ये यहाँ पे आपको दिखा होगा, ये देखिए ऊपर में, ठीक है. जब आप मॉडल से आउटपुट भी ले रहे हो, सॉरी, तो उस टाइम क्या होता है, द काइंड ऑफ आउटपुट विच वी वांट फ्रॉम द मॉडल, ठीक है, वो उसी के बेसिस पे देता है. जैसे कि आपने यहाँ पे डिफाइन किया जो आउटपुट है वो मुझे मैक्सिमम 200 टोकन्स में चाहिए. नाउ टोकन्स इज वेरी डिफरेंट फ्रॉम वर्ड, ठीक है, बाय द वे. जो एवरी मॉडल हैज गॉट इट्स ओन टोकनाइजर, इसीलिए जो अगर आपने चैट जीपीटी इनिशियल मॉडल यूज किया होगा तो अगर आप लिखते हो उसमें हाउ आर यू और वही सेम चीज आप लिखते हो आप कैसे हो, दोनों का कॉस्ट अगर आप कैलकुलेट करोगे मॉडल का, दोनों अलग अलग है, ठीक है. बिकॉज since these models are being developed by Western countries and all, most of their data is trained on English language. So there is already biasness built in these models. ठीक है, वो हिंदी या बंगाली या तमिल या हमारे कंट्रीज का जो जनरल लैंग्वेजेस वगैरह है उस पे उन लोगों ने टोकनाइजर बिल्ड नहीं किया. अभी टोकनाइजर क्या होता है कि जैसे मान लीजिए गिव एक वर्ड है, ठीक है, तो गिव का बहुत सारा फॉर्म हो सकता है, गिव्स, गिवन, गिव, ठीक है. तो इसको वो लोग क्या करते हैं, तोड़ते हैं, ठीक है. जैसे गिविंग को गिव प्लस आईएनजी, तो 2 टोकन बन गया ये एक वर्ड, ठीक है. बट हमारा जो जैसे कि हिंदी हो गया या तमिल, बंगाली या जो भी लैंग्वेज है, उसका जो अपना लिपि है या जो लैंग्वेज है उसके हिसाब से इन लोगों ने टोकनाइजर बनाया नहीं है. तो उसका जो प्रोसेसिंग, उसका जो खर्च आता है ना, दैट इज़ वेरी डिफरेंट. सो दैट इज़ वाई इफ यू ट्राई टू डू आवर लैंग्वेज एक्टिविटी विद दीज मॉडल्स, देन यू कैन सी दैट जो इंग्लिश के लिए आपने 10-20 रुपये खर्च किए, सेम चीज़ के लिए आपको 50-60 रुपये खर्च करने पड़ेंगे, बिकॉज दैट मॉडल कंसीव टोकनाइजर फॉर ऑल दोज स्क्रिप्चर्स इन अ डिफरेंट वे, ठीक है. बट नाउ अभी क्या है, आईटी मद्रास का जो लैब है गवर्नमेंट ऑफ इंडिया ने, मतलब यू वुड हैव सीन दैट in multiple government functions there will be a chatbot or मतलब language based chatbot होगा जो कि मतलब यूज़ किया जाता है, ठीक है. So all these solutions are developed by IT Madras. There is a very good lab in collaboration with Government of India. They have actually developed model also. They have developed data set keeping Indian language in mind, and they have also got their own tokenizer also. So now India has got its own data set also, tokenizer also, which is not that much bias in our language, and it can give a much better output than all these models what you have seen. So coming back over here, so ये क्या है कि जब आप अभी क्या है, वो तो सेंटेंस कंप्लीशन के लिए देख रहे हैं, राइट, मॉडल, उसको रीजनिंग और ये सब तो पता नहीं, तो एक ही साथ सारे वर्ड्स का प्रोबेबिलिटी आ सकता है, ठीक है. सो द वन विच हैज गॉट हाईएस्ट प्रोबेबिलिटी, यहाँ जो आप मेंशन करते हो, ठीक है, टॉप पी एक्चुअली प्रोबेबिलिटी करता है, और के जो है ना वो पूरे वो कैब से, मान लीजिए आपने यहाँ 25 मेंशन किया, तो जो टॉप प्रोबेबिलिटी का 25 वर्ड्स होगा उसमें से वो रैंडमली एक्सेस करके फिर वो आपको फाइनल वर्ड फिलिंग करेगा, ठीक है. सो सी दैट इज व्हाट हैपेंस. आपने देखा होगा कि यहाँ पे टेम्परेचर सेट करने को आता है मॉडल्स में. मैं आपको दिखाता हूँ, ये GCP का है, ये हमारे कंपनी का है, वी यूज़ GCP इन टाटा स्टील. सो यहाँ पे मैं दिखाता हूँ आपको. देखिए ये इनका Gemini 2 फ्लैश मॉडल है, ठीक है. डे बिफोर यस्टरडे इट हैज़ गॉट रिलीज. इफ़ यू क्लिक हियर यू कैन सी ऑल द मॉडल्स, ठीक है. तो यहाँ पे देखिए आपको टेम्परेचर सेट करने को आ रहा है, सेम थिंग जो यहाँ पे मेंशन किया हुआ है. अगर आप टेम्परेचर को यू विल bring it more towards the zero side, then it will give a more of a definitive answer, the word which has got the highest probability. And जितना आप इसको वाइड करते जाओगे जीरो से अवे, उतना वो क्रिएटिव आंसर से फुलफिल करेगा. देखिए हायर टेम्परेचर, ब्रॉडर, फ्लैटर, बट ये क्या है ना, क्रिएटिव करने के चक्कर में जो आपको डेफिनेटिव आंसर चाहिए होगा उससे डेविएट करेगा, ठीक है. सो इट बेसिकली डिपेंड्स अपॉन द काइंड ऑफ यूज केस यू आर हैंडलिंग. इफ सपोज आपको स्टूडेंट रिलेटेड डेफिनेटिव इंफॉर्मेशन चाहिए, राइट. ये नहीं बोल सकते कि कोई बच्चा फ़ी के बारे में पूछ रहा है, अल कबीर में कितना लगेगा, तो उसको आप कुछ रैंडम आंसर दे दो, ठीक है. वो एक गलत इन्फॉर्मेशन जाएगा. वहीं पे अगर मान लीजिए कुछ ऐसे राइटिंग या मान लीजिए कोई एक्सटेम्पर स्पीच कंपटीशन हो रहा है, देयर यू कैन इंक्रीज द टेम्परेचर एंड टेक द हेल्प एंड गेट अ मोर क्रिएटिव आउटपुट फ्रॉम द मॉडल. सो वॉट एवर आई एम सीइंग इज ऑल दिस इज you have to do it during your model inferencing time, ठीक है. Yes, so this was all from me for this session, जो I think you should know. For the next session we will take a hands-on. I will only request that in the meantime during lunch, if possible you make your profile on Hugging Face, and you also definitely would be having your Google account, so you just make an account on Google Colab also, because we'll be using these two things for model deployment. If you are doing hands-on, if you are not doing hands-on, if I have to show, then I can show you directly. So how? They will be not doing parallelly. अच्छा, I have to only do. हाँ, ठीक है. I will show you. I will show you real time में how application gets deployed and everything. Yes. हाँ. So देखिए task 1 है कि आप Hugging Face में अपना एक प्रोफाइल बना लीजिए, ठीक है. We will be using something known as Hugging Face Spaces, ठीक है. वो क्या करता है वो मैं आपको हैंड्स ऑन के टाइम बता दूंगा. और एक आप गूगल कोलैब में आपका गूगल अकाउंट होगा, उससे आप लॉगिन कर लीजिएगा, ठीक है. इसमें जो एग्जीक्यूट करना है एक्टिविटी, उसके लिए मैं मैम को ये नोटबुक जो है वो मैं दे दूंगा, वो मे बी आपको मेल कर देंगी या, ठीक है. ओके, देन पैरेलली यू हैव टू जस्ट रन इट, नो नीड टू टाइप और एनीथिंग. श्योर. दो हैंड्स ऑन है, सो आई थिंक विद इन 1 hour वी कैन फिनिश बोथ. थैंक यू.
बहुत बहुत धन्यवाद कुमार गौरव सर. आपने तकनीक के माध्यम से एआई को समझने में हमारे प्रयास को बहुत बेहतर ढंग से निभाया. और अब मैं लंच ब्रेक का अनाउंसमेंट करती हूँ. लगभग आधे घंटे से लेके 45 मिनट के अंदर हम लोग फिर इसी हॉल में दोबारा मिलेंगे. हाँ, आप लोगों को ग्रुप में मैसेज आ जाएगा जिसमें सेकेंड हाफ में हम लोग हैंड्स ऑन सेशन के साथ में आज 2 दिन की कार्यशाला का समापन किया जाएगा, सर्टिफिकेट वितरण किया जाएगा और हमारे कुछ अतिथि भी हमारे साथ होंगे इस आज की द्वितीय पाली में. तो फ़िलहाल एक ब्रेक लेते हैं. मैं आपको बता दूं कि जो 4 मुख्य सेशंस थे उसमें हमारे संस्थान से श्रीमान पहले सेशन में मतलब कल श्रीमान तौसीफ़ अहमद ने रेपर्टोयर की भूमिका निभाई थी डॉक्टर चंदना कुमारी के सेशन के लिए, प्राचार्य महोदय के सेशन के लिए, और मुमताज़ रिजवी साहब ने जो हमारे वक्ता थे डॉक्टर चंद्रशेखर आज़ाद, उनके लिए रेपर्टोयर की भूमिका निभाई थी. मिस्टर मोहम्मद मुदस्सर अंसारी आज के सेशन में डॉक्टर चंदना कुमारी जी के जो सेशन था उसमें रेपर्टोयर की भूमिका निभाई. और फिलहाल अभी जो सेशन चला उसमें मिस्टर संजय कुमार सिंह सर ने रेपर्टोयर की भूमिका निभाई. तो ये भी एक बहुत बड़ी बात है कि इसके द्वारा हमें जो रिपोर्ट बनानी होगी उसमें हमें काफ़ी मदद मिलेगी जिसे JUT को भेजना है. तो आप सभी का बहुत बहुत धन्यवाद, ऑल रिपोर्टर्स. थैंक यू सो मच. नाउ वी टेक ब्रेक. थैंक यू.